So that's going to start up YouTube. This thing should go, yep, there it is. Okay, so we started up YouTube. Now what I need to do is bring in another browser window. Now that we've done the thumbnail and all that other stuff, bring this in and go to at YouTube, oh bother YouTube VOD, or at oh bother VOD, and I need to open the stream up, make sure it's muted so we don't get double audio, and then pop out this chat. And that's all it takes. So easy. So now both chats will show up in my social stream blade on the browser there, and it'll also show up on the OBS site. Whew. That was nuts. So that's what it takes. That's what it takes. We can go back here and I can do the overlay with the start soon. Oh no, that's in here in setup. Why did that come up? There you go. Did I already have that up? I must have already had it up. All right, put this over here. My screens are getting dusty. Dusty. Okay, so now that I've got all that handled, I can open up Arduino. I've already got it open. Okay, I've already got it open with the weird code in it. Strange code that they're running here, and I think it's because they're not using like a sine wave library. And I think we can get away with just getting a library for this. I think that's the way we're going to do it. We'll approach it with sort of that, what is it? I don't even know. I don't know. The words just, okay, this stuff's trash. What's this doing here still? We're going to approach this with a basic Arduino tool set so that it's nice and easy. Everyone can understand what's going on and why. And we can test out the laser. I bought a laser specifically for this thing. We remember, you remember, I remember how fun it was to have a green laser in the middle. So I got a green laser. And what I figure I can do is I can drill a kind of big hole in the middle and suspend it with hot glue. And then if I need to re-aim it, I can just heat it up with the torch or heat it up with the hot air gun and then just kind of wiggle it into place so that it gets as close to parallel as we can get as a target for me to suspend stuff in the field. So this is something we need to test. This is a 5-volt laser. I don't know what the milliamps are on it. I don't like the wire very much. Why is it like this? Looks like it's in something that should be in a pointer. What's going on here? Got 2 leads of the laser there that are floating. One of them should be ground. It really shouldn't be floating like that. I could take a little dollop of alcohol on it and loosen all that stuff. Over here, we've got probably a constant current driver. So we've got a voltage regulator, I think, and then a constant current driver. Or it's the other way around. That could be a MOSFET, and this could be a constant current driver that requires a MOSFET. It could be as simple as that. But then they have provisions for a button to go on the side for like a laser pointer. And then the battery contact inputs. But we bypassed the switch. And we're soldering weirdly to this thing with flying leads and everything. I'm not going to worry about it. I'm not going to reverse engineer this and make it its best. I could move this little daughter board onto our big circuit board and do all that stuff and make this TTL controlled. But I think we're just going to slam the power on and off on this thing. And depending on how many milliamps this thing takes, we can see whether or not the Teensy can, or not the Teensy, the Pro Mini can handle it at all. This Pro Mini we're going to be putting through a lot. The Pro Mini is a decent platform. It's like got decent speed. It can do most of the stuff that your typical artist and engineer would want to do beyond cranking digital signals, although it can do that pretty well. But it's getting kind of old, and so every other microcontroller can like beat the shit out of this thing now. So I want to permanently put this thing on this project. This is a project that will fully utilize the capabilities of the 328P, but we are only running a 40 kilohertz square wave out of this thing. This thing should be able to handle a 40 kilohertz square wave by all means. So if we find the right square wave library, we can get all the complexities swept under the carpet, have some nice simple Arduino code on this thing, and then I can make one button turn on the laser, and then the other two operate the phase between the 2 square waves. So I'll be able to have it skew a variable either direction and have it manipulate the phase of the second wave. And I think what that does is that moves things up and down in the suspension field. It moves sort of the troughs and the peaks and valleys. It moves around in sort of an interference pattern, a three-dimensional interference pattern that the two waves create. Should be pretty cool. I did a little bit of reading, if you can't tell. I read up a little bit on the project in the 2,000 days since I last streamed. How's everybody else's week been going? Have you guys seen W Place yet? Place was this thing that Reddit did for one of its April 1st events, where users could place a pixel every now and then. Hey, last mile's rating with a significant amount of people. Party of 52, how's it going? We're going to be hitting the Arduino code today pretty hard. I just kind of explained all the stuff that I wanted to do today, but I can always talk about it again. Basically, what we want to do is we want to start new from a brand new piece of software and put it together so that it can run this thing with all the parameters that I want. The previous code is a little crazy. I'm a tired old geek and you seem to have more energy. Well, I haven't streamed in about 75 days, so I've had my family kind of descend on the house and things have been just too hectic. We had 2 dogs here, we had a bunch of teenagers and just a bunch of craziness going on here. So once that was over, now I have other family coming here, but they're going to distract. They're going to distract the other family that's here so I can stream, so I can actually work. So I'm streaming, I'm back. We're going to do some, I'm curious about the ultrasound levitation device with a flux capacitor. Yes, so this has a whole bunch of ultrasound emitters on either end of it. And apparently I did a little bit of reading. The Arduino, the Atmega 328P that I want to put into this PP here, needs to output 2 square waves that are in sync with one another at 40 kilohertz, which is something that this thing can do without us having to run down all the way to machine language on it, which is what the previous software has them doing, like NOPs and like software pointers and direct register edits and stuff. And it's like, no. We don't need that. We don't need that. There are audio and other tools for the Arduino that we can utilize. So I'm thinking we can either find a library or push comes to shove, I'd have to throw a teensy at this thing. I really don't want to. But push comes to shove, I think what we could do is find a library for this Atmega 328P that will be able to output 2 40 kilohertz square waves and enable me to edit the phase of one of them using 2 of the buttons. Third button, green laser. I went out of my way and I ordered a green laser for like $10. Little bit much, I know. I probably could have gotten one off Alibaba for half a cent, and then it would have come here sometime within the century. But I'm gonna wang jangle a hole right in the middle there, put some hot glue around it, and then if I need to, I can use hot air to adjust where that point goes so that it goes to the bottom hole and gives me an idea of where the center of this thing is. Because that's what we did last time. Everything eventually ends up as machine language. Yeah, but I mean, for the human being, we really just don't want to, we do not want to deal with machine language. It's just, I don't want to have to take notes in order to figure out what's where. It looks better than a red laser. I have a bunch of red lasers we could have probably thrown at this thing, but green looked cooler. Blue would be neat, but that's a lot of ultraviolet, and the weakest blue laser that I can find is like 4 watts, because they're all used in like DLP and like all kinds of other like crazy telecom applications. So now the market is skewed towards really, really super dangerously powerful blue lasers. I don't want that. I hope this thing isn't very powerful. I don't know what this is. The typical way, Chad, if you don't know, the typical way that a green laser works is that we create an infrared laser beam, which is real easy for us to do. It's a lot of silicon electronics emit infrared or get befuddled by infrared. So it's very easy for us to take silicon wafers and output a whole lot of infrared, right? That infrared goes into a crystal, and the crystal shifts the frequency down to green. I think it's down. I don't think it's up. You can't create energy. It compresses it down to green because of refraction or whatever. And then you have a green beam coming out the front. So that's how they typically work. Blue lasers just use phosphors, I guess. Red lasers are just inherent of the materials. Green lasers you create with an extra crystal. That's why this piece is so big at the front of this thing. But green is more visible to the human eye. Blue lasers have ultraviolet in them, so they're a little bit dangerous. So red is old news and hard to see. So, so here we are with green. And I'm sure I could have gotten yellow or purple. That would have been fun too. I think mostly we're going to be coding today, though. Let's see how powerful the green laser is. No, I got to save that for stream. I got to save that for when we actually get started. So yeah, welcome to my shop. This is Oh Bother. I have a bunch of stuff surrounding me right now. It's literally everything I own in this life. This is where we hang out on several weekdays, except for Wednesday and Monday. We work on projects. I've got a couple synthesizer things that are in the works. I got like a $20 kit, $30 kit for a MIDI decoder for the synthesizer. So we can build that, get that working, and then use that as a stepping stone for everything else we work on, because then I'll have a little keyboard that I can make control voltages with instead of having to set arpeggiators or sequencers or anything like that. I can just hit the keys on the keyboard and we can listen to what comes out of the other end of the synthesizer. I think that'll be fun. Project for the future. High power 7-watt blue laser. No. I don't do, I mean, yeah, like great, that should be great, but high power blue lasers are not safe. You can reflect one off of a white wall and it will throw so much ultraviolet back at you that it could hurt your eyes. Ultraviolet is insidious like that. We don't see in those frequencies, and so our body doesn't react to them. We don't squint our eyes or anything like that. High power visible lasers, typically, you know, you've got a couple safety systems. You got safety squints, eyelids, and just looking away because it hurts. That generally helps humans not blow their eyes up when they walk out into the sun. But the insidious part of sunlight and blue laser light is that it has ultraviolet in it. And the ultraviolet, we just don't see. We don't see it. I mean, like, I've got these lenses block ultraviolet. You don't see it, except like on thermal imagers, they're not clear because they're plastic. Right? So like, there you go. See, they're transparent on thermal. That's long wave infrared. It's a little different than ultraviolet, but still the point is it's a frequency that we don't see. So these are perfectly optically clear to me, but to long wave infrared, they are as opaque as you can get. That's the same deal with ultraviolet, and it's insidious. It's insidious. A project like a 7-watt ultraviolet laser can easily burn plastic. Ugh. The laser for burn the subs is 1.4. I think it's a full 2 watts, and we dialed it back a little bit because in order to turn wood into creosote, in order to burn characters and lines on it, it doesn't take a lot. You just have to put it down to a little tiny point, and that's enough to fry the wood. But that's going to release a lot of ultraviolet, and so I've got laser safety goggles. I've got all kinds of means. Mainly is the one that I'm facing this direction and not towards burn the subs, because you'll see it lights the whole room up blue when it operates. Full solar eclipse will really bake your eyes also. Don't stare at that thing. Pretty amazing to see. Yeah, I don't want to look at this directly. Use pinhole viewer. I have some eclipse glasses sitting over there, and they're just like thick plastic. This is really thick plastic. I wonder what frequencies get through that. Hopefully none of this gets warm. I was hoping to use this fan on it if I really need some air movement. I don't think we'll need it though. I have to 3D print something to hold it up. It's also, I think, 5 volts, so I'd have to hook up to like this over here. We'll figure it out though. We can get this done. One of the ways they were talking about adjusting this thing is by upping the power into it. Wait a minute. What the deuce? That's an LED. I just discovered something about this weird... What the... I never knew this had an LED in it. That makes it so much more special than this project. Oh well. I guess we'll have to use it. I just don't know. Are there leads for the LED? Is that what these front 2 leads are? That must be what the front 2 leads are. Oh my god, we've got to hook this thing up to some kind of switched power in order to, and a resistor in order to light up the LED. I never knew it had an LED. Oh, you discover new things every day, chat. That's a cool switch then. Ah, it's too cool than this so much cooler than this project. Ah, I never knew. Here, let's put some leads on it and get it to light up. Let's put some leads on it and get it to light up. Multimeter is a really good tool for testing out what the polarity of your LEDs are, because sometimes they're either manufacturing defects that are wrong, or one of your the LED box that you've labeled red does not contain only red LEDs. They tend to wander if you have a bunch of the same types, or if you have a bunch of clear lensed LEDs sitting in a bin and you don't know which is which. You can use a multimeter to determine what the polarity and color of the LED is. And that's just by tapping the leads. The multimeter will attempt to put a very low voltage through the connection in order to figure out whether or not, figure out how many ohms are in there, right? It uses a Wheatstone bridge in order to put a very small amount of current through a trace in order to figure out what the requisite resistance is, scaled from very tiny voltages to very large voltages. And so in doing so, it will figure out what the forward operating current of an LED is. And there just isn't on this one. Okay, okay, no, that's, you know what, that's fine. Maybe it's from the common pin. Go over here to common. Or does it have to be switched on? Nope. Nope. What's up, lines and squares? Hope you're all having a nice day. I can't believe you would come in here and say that to me. To me. Why is my thing not working? Why the thing that I do not work? Is this got a weird pinout? Like it could potentially be using the common pin over there. We already ohmed it out for the common pin. No. I'm on to you, LED. I'm gonna find out how you operate. Unless it's already blown. Maybe that's why it was in the whatever rejection pile it came from. What? Best way to look at an eclipse is to get a good small mirror, shine it onto a screen in a dark room through a tube. I mean, you want like the pinhole viewer. You want a pinhole viewer because that'll do all of the optics of focusing and everything with just one little mechanism. You just put a pin dot in something. Using a mirror with direct sunlight, I mean, I guess they've been doing that for centuries, but for like microscopes and stuff. But I don't know if I'd say go out and do that. It could be that like something is shorted, although this doesn't show shorting on the front legs. The front little legs that I soldered here, they just connect to one another? No, they don't. Could it be that these are actually what's connecting from here to here, or from here to here, and the center one is actually the common for the, no, that's not it. So I got like kilo ohms on that. Could it be an integrated resistor? That could be the problem here. This power switch might not work the way that we think it does. I don't know how I'd find a part number for this switch though. Square SMD, single pole, single throw, LED, push button 90-degree SMT switch. Yeah, there's no chance. There's no chance. I'd have to bring dimensions into this. All of these terminologies are variable. No, I don't have any information on it. I think it might have come from like one of the bargain bin, like extra parts things, or it came in with the other SPDTs or SPST switches that a friend of mine got from SparkFun in the early 2000s. More chance of finding Elvis in a supermarket. I just saw that there's an LED on the end of this thing. Look at that little guy. There is an LED on the switch, which propels it to far cooler status than the rest of this project. But I've already soldered it in, so we're kind of married to this switch. And I want to make it work. It's nice to use some of your cool parts for some weird projects sometimes. Although, damn it, this is way cooler than this specific project. So I thought it would be the leads at the front. What is that? I guess I can't show this on the microscope very easily. I've got 3 leads at the back and 2 in the front. 2 in the front, 1 on the back. Get so much booty, I don't know how to act. But I've already got these wired up, and it's pretty clear that it's common, normally open, normally closed. Or is it? And it could be that there's an integrated resistor into this thing, but I've got contact, contact. Did I wire this one up to the case and that's why it's not working? Yeah, so I've been trying to multimeter it. So you can't see everything at once. Hands in the way. Move back. Move back, move back. What is this called again? It's not a Hoover. It's, what is the name for this kind of synth line? Maybe like Chicago style or something. That's not really Chicago style. It's acid synth, I guess, is what you would call it. Wasn't there like a vacuum style name for this thing from the Brits? I don't remember. I don't remember. Nothing from the 2 leads on the front. Reverse the leads and try it with both. It's possible that, yeah, it's got a more complicated lead setup to it. So let's go back to the normally open and try it to here. Nope. Try it to here. No, I would get something if it was reverse, right? You know, maybe it just goes through the front of house stuff. Oh, 1.5 mega ohms. No, 1.5 meg. Reverse them again. So you could interact with whether or not the switch is flipped. Connected. Wait a second. All right, we got a mystery on our hands. I think I might have to, they're usually entirely separate. It's just I got a different, I got continuity for this way, which is not great. I think we need to pull the switch, which I think I can pretty easily do. It's tough because there's leads all the way back here and all the way up here, and I don't want to melt this. The stuff we're doing today, we can do, yeah, I'm still looking at W place as well. There's a thick Azrael right next to my place here. And if you guys can find it, there's a little kitty cat face right near where my neighborhood is, as well as some kind of a cursed, probably picture of a rat. I think that's what Groovy Something thinks it is. That's all the information I'm going to give you, though. No, it's all Deltarune. I think, so if you guys don't know, wplace.live is something like Reddit Place, where they had an April Fool's thing, where they had a project where you could place one colored pixel, what is it, like a day? And so boy, howdy, the number of botnets that got started up just to put like Coomer anime pictures up on pixel art, up on the place, it was insane. There were like wars and factions and all kinds of just crazy shit going on just to put pixels up on a screen, right? And that was a pretty big screen. It was a pretty big thing. They expanded it over the years, and now there's something called WPlace, which is the whole world where you can place pixels, and it's 95% Deltarune because the game just came out, 20% Homestruck because of the announcement with Visipop animating Homestruck, and then the rest of it is split between anime and niche. Nice lab, thank you very much. It's literally everything I own. I have been lazily playing Undertale, but I've also been playing Abiotic Factor. We're eating good this couple months right now. I've been playing a little bit of Abiotic Factor. I'm making a lobby base, so smaller area, and I'm going to try to layer it upwards as I kind of grow and move through the 1.0 version of that game. It's been very cozy and very interesting. I've had a good time of it. Single player. WPlace came out at just a time that I was lazily playing through Undertale. I've taken a little bit of a break, trying to 100% the first 2 chapters, at least on a peaceful run. And then I'm going to go back into it and do it again. But I'm trying not to. We've got a year until the next chapter comes out, and then God knows how long until the rest of them. So I'm taking my time. I'm nibbling on this content. And then WPlace came out, and it's just madness. There's so many weird things in there. Rabaz looked at a little bit of it at the beginning of the stream, and I was kind of like monitoring that a little bit in the side while setting up stuff here for stream, and it's crazy, the type of stuff that's out there. I appreciate the local stuff, like where if you zoom in on Philadelphia, you get a bunch of Wawa logos, right? The problem is, and this is what happened with Place and what's happening with WPlace, is that it's just a bunch of factions of bots getting together and mashing their skulls together and fighting it out. Like, I don't know how many bots they literally just pointed at a different website in order to get it to operate WPlace instead of Place and do their bidding. So you've got like the Sistine fucking chapel going up in some places, and you've got Deltarune sprites that are absolutely fucking ubiquitous throughout the entire world, which is a little bit, it's not good. It doesn't represent the area. Like some of the most fascinating stuff, don't go to New Delhi. The most fascinating stuff is when you zoom in on a local area and you've got somebody saying like, Pat lives here, and like, Pat's a big jerkhead, and like, this place sucks, and people like circling things and filling stuff in and doing like, in the middle of New York City, somebody did like just like a one lot, walled off like back lot. Like it was just like this cool little piece of pixel art that somebody hand drew instead of just like, you know, a picture of somebody's testicles that a bot put up over the course of a week. It's, I don't know. I like the less body stuff on there. All right, so the distraction at the beginning of this stream is this switch. We discovered that this switch has a life of its own, and we need to get it out of there. How do you remove a surface mount switch without harming it? I think what I can do is get rid of the solder in the back and maybe use hot air, or I can get under it with a knife. I think I need to get under it with a knife. Yeah, there's so much. All right, I'm gonna mark these so I don't have to look at them again. We're gonna put ferrules on these in the future because I'm gonna remove the top layer from the bottom layer. So I'm gonna get a Sharpie, mark the light one, and then mark this, just like that. Falsetto. I can't wait to get that MIDI thing in because then I can actually do some music in the same vein of me unironically liking Deltarune. I do. I unironically like it. I'm like Joel, who's also, for some reason, Joey is completely ubiquitous. I think that's because of his Deltarune fandom. I'm surprised I'm not seeing more Voices of the Void because, who was it? What's his name? Markiplier did a Voices of the Void stream. And so there's a lot of new voices in Voices of the Void. It's not so niche anymore, which is totally deserved. That game is awesome, except, and this is a very mild except from Oh Bother here, the except on Voices of the Void is that they use all the same like stuff. It's basically, what is it, Source 2 engine, all the Half-Life 2 engine stuff, which includes incredibly loud sound effects. The SFX is so unbalanced, it's just harsh. And I don't know what it is about Half-Life 2, what they did for that. There are bigger Half-Life 2 fans in my chat because we're a bunch of old idiots on the internet. And so that game was like prime of its time when it came out for us. We're so old. Anyway, yeah, the SFX in that game are very harsh. I don't know what it is about the SFX. They need to be run through like a compressor or something. Hey, Mahalo. Hey, Big Gizmo. How you guys doing? How you folks doing? Be a little bit more neutral on that. We found out that this switch is harboring secrets. It has an LED. There's an LED. I didn't know there was an LED. I'm gonna get this thing out of here because there's an LED on it. That makes it so much more special than what I thought it was. So I think the way to go about this, we'll use the solder sucker because it's economical, right? Well, solder braid is super expensive, and who the fuck knows what's gonna go on with terrorists in the future. Sorry, I shouldn't curse as much. I shouldn't curse. We're not really a cursey show, except when the chips are down. When the chips are down, I'm gonna curse like a sailor. But yeah, there's something else in this switch, and so I'm gonna get this thing out of here so we can test it outside of. It's not broken, and this is the ultrasonic levitator. We've done this project before. Obviously, I've got all this stuff 3D printed for it. What I've decided to do is to put it back together, kind of in shambles, because that's the kind of project that it is. I only come here for the cursing. Oh, okay, well, that's a different story. Look, if I can have like 350 viewers, I will not worry about cursing anymore. You know, I put pooping and farting in the title today just to entice weird perverts to come into my stream. But yeah, I've been watching the Joel Varg Skeletor playthroughs of Deltarune, and they've been really fun. All right, that's not really working, is it? It's not really getting everything. I would like to get my X-Acto knife under that so that I can separate the pad from the pin. So I think what I can do is come in here like this with very little of the heat-wicking stainless steel. Oh, it is wicking way too much heat. No, this is a weird technique. There we go. Hey, it worked. That's what I love about surface mounts. Sometimes you can come up with kind of a harebrained technique and it actually works. Did you find it this? No way. There's no way. You got to tell me how. That's one of the deals here. If I'm going to use your link, you have to reveal the secret sauce. Did I rip the pad? I think I ripped the pad off. I think I got the whole pad there. Stainless tweezers to chase hot solder off shorted pins. Interesting. That does sound like a good technique. All right, hold on. Let me open up this one. The number of viewers means nothing. You will curse like a drunken sailor when the soldering iron drops on your toe. I've never dropped a soldering iron on my toe, but I did have it in my mouth when I was working on a giant LED globe, and I forgot which side. It was exactly like this iron. I had it in my mouth, and I forgot which side was the iron and which side was the cord. So I went up to grab it, and I put a divot in my palm. Damn, how you find that? Ben Gizmo will often, like, usurp the entire point of the whole channel just in being enthusiastic. Yeah, he definitely found it. And he's often right, but I'm often too stubborn to even take the advice or whatever. That is it. What the fuck? How did you find that? I find that hot molten solder always finds my hands. That's a horrible place for it. Right angle, illuminated, latching. Latching might have been a good keyword. From Little Fuse. The Elam series. Isn't that Elam? Elam is the name of the spy, Cardassian. Elam. Why am I blanking on the name? Garak. Ilum Garrick. Especially the lies. The Ilum series right angle, blatching push button, medical communicating, blah, 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 blah. Okay, let's see what the pinout is. Show me the pinout. Show me the pinout. They always have to obfuscate it. They never let you just have the pinout. Bidirectional, I doubt. On momentary, pins 5 and 1, 4, 3, 2, 5 and 1, and of course they don't tell you where it is. There we go, 5 and 1. So this entire side, so we've wired this thing wrong. Yeah, so the question is it bidirectional, two-color? Because that we can play with that. We could put that up to the Arduino. I just need to free I need to free this side. This side doesn't matter. Well, let's get it off of here and test it, because I've already got the pins ready to go. You learn something new every day, huh? Since it's surface mount, I can just kind of get this whole thing molten. Just got to be careful not to rip up pads. You can also kind of just like walk it. There you go. All right, it's in good shape. We got to discover what's going on with this guy. Yeah, it's you generally, like when you get a part like this, you assume it's going to be the cheapest version of the part. Although that does look, well, you can never judge a book by its color, chat. If you think it's bi, it's probably not, and you're going to embarrass yourself if you mention it. Just let it identify itself using the multimeter. So let's put the multimeter out here. Was that an entendre? What was he saying there? I don't know if he was saying something, bro. I don't know. Is Bother woke? Oh my God. Oh my God. Okay, so we can't really see the LED from this angle. I assume it's going to illuminate what's right in front of it. It probably won't be that bright, but we can just hit it with one of these. And one of, oh, I can't even see the other lead. Yeah, it's so dim we can't really see the illumination, if it even is illuminating. Let's try it the other way around. We just say Garrick and everybody knows Quark. The rules of acquisition. You don't post the rules of acquisition to me, human. I don't see any illumination on this. Does it need to be pushed in? Donk. Apparently there are 1080p AI rips of DS9 that are out there. You got to find them on the high seas, but they're pretty good. I may or may not have witnessed the 720p version, and it's pretty good. It doesn't look like, you know, horrible rips of 90s TV, which is great. Getting to these leads is the hard part. Now the question is the LED dead and that's why I was in the pile? Or is it actually fine and this thing doesn't work? Wait, what? No, that doesn't work. That doesn't make any sense. Okay, so that didn't work in either direction. Are these numbered? Sometimes they're numbered on the little press-in. Although it looks a lot like those are the two LED leads, doesn't it? Which just connect the entire motion of the switch. Let's just test with this. Nothing. Nothing. Flip them. We might have a dead LED, in which case this is a perfect candidate for this project. How's everybody doing? It's been a minute since I streamed. I had family descend upon the household, and things were just too crazy. We had a Finnish Spitz, my brother's dog, as well as Willow, who is a corgi, and so there was this feedback loop of barking. Oh, wait a minute, I'm on ohms. What am I doing? I've been on the wrong mode. Oh God, guys, I've been out of it for too long. I've been out of the game for too long. I was not on diode. Now I'm on diode. I'm on diode mode now. So now we'll see enough light that we can illuminate my finger here. Look into my eye. Here and here. .8 volt forward drop. That's insane. Let's try it the other way around. And 1.8 should be. Yeah, the Corgi and the Spitz, there's a picture of them in the pet section of the Discord. But they would feedback loop on each other and go crazy. It looks like we do have a bidirectional LED. We just can't see it right now. Okay, so let's try this. Flip it up. Pinch that. Touch this. What we can do is hook each of these up to a lead of the microcontroller, and they will, depending on which one we ground and which one we make into an input pull-up, or just, you know, make into 5 volts, we can illuminate this in any direction. You saw it red? I didn't see it at all. Hold on. I don't doubt that you saw it light up red, but I didn't see it. I didn't see it. One day, Germo will raid my channel. One day. I had a Rabos raid a long time ago, and it was chaos. Absolute chaos. They're like, oh my God, you're at the top of the category. I think when Burn the Subs comes back, yeah, there you go, you were right. Okay, so red is in positive forward direction. I'm gonna take notes on this real quick because we won't remember. Well, maybe I'll put it into the microcontroller code. So let me just do a quick little notepad. Florida, where they shoot rockets off, is pretty good looking at W Place. I would imagine that you would get some. Well, okay, I don't believe that the local people of any given area are actually the ones filling out. That's not what I wanted. I wanted paint. I don't think the local people of any area are the ones filling out the majority of stuff. I think they go to their bot and they go, hey, Google AI, I need you to W place me with this botnet a picture of Hey Arnold flashing his butthole over Cape Canaveral. And Google AI goes, sure, I can do that. Here's the code. And they run their code with 1,000 bots, and it goes in there in 2 days, right? And they just kind of fart at their computer the whole time. That's my theory of how most of the stuff is going up into W Place. Snipping tool. Dibba dibba dip. Good song. Okay, so this would be from positive in the front. Bigger line. Zoom in. Enhance. Enhance. And this one is the anode. This one is the cathode. A plus, C minus. We don't get good grades here. That's how I remember A plus and C minus. And then if we have an opposing LED, A plus, C minus. So we reverse it. Green. I saw that for just a second. Did you guys see that? What you listening to? So this is a cool ass song from probably 10 years ago, maybe 7. That's green. So there's green. Okay, so but the mix is Big John at District. Big John is a buddy of mine who did DJing for a little while. I don't know if he's still doing it. He might be, but this is his mix right here. We are how far into this thing? Does he accredit? Some of these SoundCloud things actually do give you the credits for the tracks. I don't think this one has it, but it's about 52 minutes, 50 minutes into his, are we really 53-minute intro already? Wow. Yeah, A plus, C minus. anode positive, cathode negative. Did I get that wrong? I think I got that right. We'll finish the intro in just a second because it seems like we're already working on the project. So let me just get this out of here and do a quick little intro. This one, and the mix is getting better and better. It's a very good mix. I like it a lot. But I'm gonna lower the volume on this thing. It was only posted 3 years ago, back when Joe Eel updated his Deltarune Chapter 2 through. Sorry, I'm engrossed in that right now. So, A to the K, Cypress Hill. That's a good one. Setup, start soon, goes away. Hi. Remember me? I stream. Do you remember? Do you remember when Bother? Do you remember when Bother did that thing where he like streamed? It was like a month ago. It's been a tumultuous month. I've had a family orbiting the house. It is that time of year when they just decide to stop by, which is fine. It's always good to see people and know that they still exist. My nieces and nephews were here, and my brother and his wife and their dog, and it was crazy, 200% of the day. And then they'd go somewhere else, and I go, but I'd still have the 2 dogs. And so I take the 2 dogs for a walk, and they're going in opposite directions. I look like some kind of a cursed semaphore person in the middle of the street, while these 2 dogs just basically treat me like a maypole. But that's all well and good. They've left. They're gone, and I drank myself to sleep. We're back, and we are ready to stream again. This project will not die. It's another one of those projects that won't die that we dug out of its cask of a Montagillo in the back area there while trying to clean. And this is an ultrasonic levitator, a sonic tractor beam. These are cool little projects. You get an absolute metric fuck ton of ultrasonic emitters, and you point them at each other, and they create an interference pattern. And that's what most of these ultrasonic emitters are really good for, is creating an interference pattern, because they create very high frequency noise that we can't hear. And when those high frequencies collide with one another, they can either make audible noise, which was the original intent for all of these drivers, or you can create high and low pressure zones. And so I'm trying to put this thing together so that it can create high and low pressure zones, and we can kind of put this project to bed. And then maybe one day I will pull all of these emitters out again, and we'll put it on an array, and we'll try to make the thing that makes you unable to give a speech, because it will throw your audio back to only you, and then you hear your voice on a delay, and it has a psychological effect. That was the original intent of this. I made the levitator because it's a little bit more twitchy. The laser speaker, they're called, is not as visual, right? Yeah, it's basically, I really want to make that speech jammer, but it's not really a Twitch project. That was a project for when I went to festivals, and people would go around with megaphones, just like, verbally abusing everybody around them. I wanted to be able to shut one of them down without people knowing that that's what I was doing, because that would be hilarious, because they are on a megaphone. And so you hear them go, oh yeah, and you over there, what is that, I can hear, I can hear my own, I can hear my own voice. And so you just shut them down completely. I would have loved that. Sometimes you have this great idea for a project, you just don't have the go-get-itude to put it together. That was me. I bought all the parts for it. But we got the ultrasonic levitator to work, and it's kind of a really cool looking project, and especially for Twitch, where we can spend half a day making little pieces of little drops of water float in the air. Cool, right? So I'm trying to resurrect it, and I'm doing kind of a Bother screw up path on this. I'm what's that? Isn't throwing a voice also a potential thing these ultrasonic speakers do? It's called a laser speaker because what it does is you've got a sound front, an expanding front of sound waves that are in ultrasonic. And when those highs and lows of activity in particles get together, they either tamp each other out or enhance each other. And they can do that at a frequency that is audible. So you can have it emit ultrasonic as a carrier wave, and then along the path, you have a normal volume audible wave coming out of those interference patterns. And so you can aim that at somebody, and if you have one of those parabolic microphones, those spy microphones, you could get only their voice, and you could throw their voice to only them, because they're standing up in a crowd. And so it's insidious. I think it would be actually very funny, but I never got around to building it. It's only a matter of rearranging this setup in sort of an ultrasonic speaker. I'm not doing that right now. We're trying to do the levitating thing because it looks cooler on Twitch. Seen people use them for art exhibits, directed down in front of an exhibit so only viewers can in front here. Yeah, and it's also used for some naval weaponry, some discouragement, and also on riots and stuff too, they use them. But it would be really funny to do the psychological speech jammer. Not take it anywhere near riots. I wouldn't do anything like that. It was literally just because people on megaphones had too much of an ego at festivals. But I'm not doing that. I'm not doing that right now. Stop being so curious about the clearly cooler project. We're working on the ultrasonic levitator, and what the ultrasonic levitator apparently does. Oh, we're not. Okay. The ultrasonic levitator uses an Arduino Pro Mini in order to make a motor controller operate all of these ultrasonic devices. And we looked at the code. We kind of resurrected this from being completely broken by shoving some carbon fiber rods into the vertical pylons, which made them so much more stable. There's still a bit of a gap there. There's a bit of a gap between them. We might be able to get around that by changing the phase of the square wave a little bit. Generally, what's supposed to happen, and I did my reading on this, the Arduino is supposed to output a 40 kilohertz square wave, two 40 kilohertz square waves, where you can control the phase of one of them to be off by just a little bit from the other. And they're supposed to be synced up really well, and the Arduino is supposed to be able to handle that completely. Who knows if we can get the Arduino to do that. They did get the Atmega 328P to do that using some like weird machine code stuff, just generally stuff that I don't like to do with an Arduino. So what I want to do today is I want to take this back to square one and build a program for this. God, Flatulent Gonad told me that he put his computers in another room so that he didn't have to hear it constantly ramp up and ramp down. And behind me, that's exactly what my computer's doing because it's freezing down here. All the cold air goes to the basement during these hot summer days. And so the computer is periodically turning the fans on full and then backing them all the way off. And then a minute later, turning the fans on full and then backing them all the way off. I'm listening to this behind my head and it's driving me nuts. Sorry, if I break psychologically, you guys know that that's why. It's nothing to do with chat. It's just the general weight of the stress of things on my head. We should convert that computer, by the way. We should convert that computer to a wall-mounted computer. I think that would be better as a wall-mounted computer. I've got a space where I could put it up on the wall right next to my desk, and if we could give it a larger reservoir and actually put that in a spot that's above everything else, then I won't have to do the water bubble dance with my computer constantly. Maybe something for the future. But anyway, point is, we're going to do programming today. We're going to do some hardcore programming. I went out and I bought a $10, not that stuff, $10 green laser. Because when we did this before, we used my little like adjustable green laser. You could adjust it in the X and the Y in order to kind of like make it do cool, well, make it hit properly. I bought this off of Amazon for way too much money. This is a green laser, 5 volts. Let's take a look at it right now. A 5-volt green laser. Oh, and I got these. These are little pinching tweezers. They're really good for this stuff. The wire wrap wire, I can basically pinch it at the tip over here where it pinches first. I can hit it from 2 sides and then pull, and it'll strip the wire. I don't think this will work here. That might. 1, 2, pull. No, it doesn't work. This stuff is a little too soft for it. Yeah, it doesn't work there. But hopefully those will work when we do wire wrap wire circuits. Those could help neaten them up. Just gonna leave long leads on that. This is cheap wire, but and then hit this with 5 volts from the power supply. Why are you not? Oh, there it is. It takes a minute to turn on because it has huge capacitors. Huge capacitance. 11, 10, 9, 8, 7, 6, 5. 5 volts. 6 amps. Well, okay. And we got to see whether or not the milliamps from this little laser are too much for even itself. Check my leads. Oh, turn it on. Boop. That's a pretty substantial amount of green. That is a bright laser. It's a third of an amp. It's 300 milliamps for this thing? Whoa. That might be too much for the Arduino, the Atmega 328P. So let's look up Atmega 328P max current. Turn that off. Yeah. I don't have an IR sensor to test that. My little laser pointer with the adjustments on it, I probably should have just bought another one of those. Okay, so we're gonna have to use a transistor on it. 200 milliamps. We've got 300 going into this thing. I'll probably have to put in a PWM signal to it too. Oh, when we tested the switch is not what we thought it was. So it's actually wired like this, and this one is red. And then this one's green. That's for future notes. Those green lasers are sometimes 80% invisible IR light. I've got a spot in my eye from looking at the dot just now. I don't know. I don't have like an infrared card to measure it with, though. That's the thing. So we're going to have to revamp the area for the button. We're going to have to program the microcontroller. The microcontroller is going to have more cool stuff happening, so we're going to do that right now. We're going to do the programming, because what we're going to do is put this microcontroller onto some breadboard, some solderless breadboard, and then we can throw code at it until something happens. Yeah, enough to harm your eyes. I thought it was with blue lasers, the ultraviolet was enough, but I guess the green lasers can also throw out some additional infrared. All right, so that's the story. That's where we are with this project. We got enough stuff to do to kind of fill a stream with actions instead of words. I haven't gotten anything done on any of the projects over the weekend. I did a little bit of research. I'm beside myself with anxiety over not getting stuff done, but I guess I needed a break. I guess I needed a break because I feel much fresher and all this stuff coming back to it today. So we know what that has. We know what this has. This needs a little tiny prototyping board. And I guess what we'll do is grab this one. Get rid of all the shiz, all the stuff that we don't need on this one. The LEDs we should probably keep on this. Maybe. Maybe not. I don't really know. I'll just get rid of all these resistors though in the meantime. Yeah, we got to get it farting and pooping. We got to make that baby monologue. Get out of here, button. I mean, do we keep one button? Let's not get caught up in the wiring. The coding is going to be the big part about this. So all I need is a place where I can stick the Arduino where the sun don't shine. So let's get everybody off of this board and just chuck this thing right up at the end here. Because we're going to basically take this over to leads. Not like the location, I mean like the power leads. Oh, but because of the little thing that the underslung right angle header, it doesn't fit. The cheese on toast tag? I got that directly from Flatulent Gonad. It's a Roots Maneuver reference. Well, well, well. Okay, let's get a female header on this thing. So I need that in order to plug it into the breadboard at all. And then we'll do leads from the oscilloscope because we need to measure frequencies. We need to get that 40 kilohertz out of this thing. That means I need pins. Pins. Ah! Knocked something over on the top shelf. Okay. Let's see here. I had a metric buttload of these things, but I guess my collection over here has dwindled. Let's go get some from the archive storage. They're just sitting right here in front. So I just need to literally get up, reach over, grab the thing, and then throw it. There you go. By the way, the oscilloscope is still booting up. It's still booting up. It takes a full minute for that thing to boot. Oh, that's not looking good. Wait, these are the wrong one. Okay, so somewhere else there's a collection of the opposite header, the email header right here. Move this thing over. That would be these. Well. There, now I got plenty. I'll grab one for me. This is what I mean. Order headers in bulk. Order them in bulk. Whinge about the money for like a month or two and then forget what you paid and then use them as if they're disposable. You get a full month to complain about it to your heart's content, and then you just eat the costs that you'll never get back and go on with your life headered with enough headers that you never have to think about it. Yeah. Last bought headers about 6 years ago due to another batch. Yeah, but the problem is I kept ordering them and they kept being this kind with the small hole. There's a version of this that has a large hole that can accept a square header pin. And this is not that, and I wasn't able to find it anywhere. I just couldn't find it. And I kept ordering it, and like people in chat would suggest, like, why don't you order these? These are the right ones. And I'd order it, and they were the wrong ones. And so I kept buying these little round ones. They are better, but they are not compatible with square pins. Yeah, like they're good and all, but oh, damn it. Tried to take a shortcut. Never take a shortcut. Put the one pin back in here. I tried. So we are going to start this from nothing and program it up completely for this project. So all I needed was a little bit of rise from the header pins, and this will barely plug in. It'll probably pop out a few times, but it's enough that we can get some flying leads onto pins and see whether or not this thing is able to do what we want it to do. Beauty. Okay, so now that's plugged into the solderless breadboard. So if you are, and I have not seen any names in chat from people who are starting out in this from nothing, and my nephew bought an Arduino kit for the duration of them being here, and my brother and I could not instruct him very well, and I feel bad about that. The thing he bought was a little automated home thing, and the instructions were bad. It was for like 4 generations ago Arduino, and a lot of that stuff is going to apply to what I'm doing today because I do stuff in a bit of an older school way with Arduinos. This is going to be kind of a low-level programming thing. I am going to move fairly fast for people who don't know what I'm talking about. Unfortunately, this stream falls into the category of, I like the words you're saying, Magic Man, but I don't know what they mean. That occurs quite a bit in this realm. I tend to babble. I talk quickly, too quickly for some. The subject is not necessarily exciting, but the results are kind of fascinating. You know, every time we do something with this stuff, things happen and we get closer to a project and we're building something from nothing. So hopefully you guys can find value in that, those who don't know this stuff very intrinsically. We are going to start this from square one, just in case I happen to be going at a pace that anybody can follow. So what we have here is a solderless breadboard. It is basically a bunch of rows of metal clips. And these metal clips go for 5 pins. You have versions of this that have power supply lines on the edges. It makes building the circuit on the solderless breadboard much more easy. I have made daughter boards that help hold parts in place and let me test things. So if I want to throw an LED onto a line, all I need to do is ground one of the pins and put power to another, depending on what I want to accomplish out of the thing. We have here an Arduino. It is basically a test bed for a microcontroller. Microcontroller, pinouts, pins are on banks. The microcontroller does one line of code. at a time as per the instructions that we program into it. It has what's called a bootloader, which makes it a little bit easier for us to load code onto the microcontroller. And since it's Arduino, it takes a lot of the setup into the background. That's the whole advantage of Arduino. It's why do you guys do everything with Arduino? It's just blog bait. Well, no, it helps us skip some of the more pedantic steps at the onset of using a microcontroller. It used to be engineer would sit down and go, oh, they well into their adenoids, they would go, oh, I need a microcontroller to program or to make this washing machine operate. So what exactly what's the quickest signal I'm going to need? It's this fast. All right, so I'm going to go with an 8 megahertz microcontroller. This one's pretty common. Let's get the clock speed here. So what clock do I want to buy? I want to buy this megahertz. And so that corresponds to this flag getting set here. I'm going to use timer A and timer B. So I have to initialize them using these flags. And on and on for about 600 different parameters. And then you finally load something onto the microcontroller and nothing works and you bricked it because you set one of the setup flags wrong. There are things called setup flags that help tell the microcontroller what it is and what features exactly you're using on a microcontroller. There are many common features among families of microcontrollers, like specific timers. Sometimes they try to make your life easier in some ways, but all of these different things, like they can brick your microcontroller and they don't share across different platforms necessarily. You don't know what's what. And so I think 2 Italian guys sat down at their local bar and went, meet me at the Arduino bar. Let's figure something out, like the basic stamp that can take C code. And so they put this whole thing together using Java so that it would work across platforms. And they made a microcontroller where you can just sit down, tell the IDE what you're using. Arduino Uno, fine, go. It will do a little bit of a checkup to see if you got the right thing. You can throw code into it immediately, and it just has sort of common parameters that it's set at. Right, it takes all that complexity and it just sweeps under the carpet. You don't have to think about it. And some functions are behind like specific, floor. There's like a floor and a ceiling function. There's stuff that makes your life just a little bit easier programming wise that the typical Arduino, like the AVR dude programmers, they turn their nose up at you about. And I think there's no place for that at all in this hobby because it's already complicated enough. Something that can have my 12-year-old nephew sit down at a computer and be able to actually get something to happen on the other end, like in a couple hours, is absolutely amazing, right? Imagine that. They did a wonderful job on the Arduino, and I love it. I love it to death. I am a professional electronic engineer who knows control systems algebra and has a degree in it and received a paycheck for working in fields such as that. And I still love the Arduino because it is such a nice universal platform where you can throw code at a problem and rapidly prototype something without having to do all the minutia. We've done the minutia too. On the show, we made an RC motor controller where you can get the range of PWM programmed into it. You can do all these different things. And that was using the ATtiny85. We had to go down to the level of using the individual timers in order to time out cycles of the microcontroller. We've gone to that level of complexity before. It's not necessary on almost every project. So what we're going to try to do today is rescue this project from that level of Arduining. What they've done in here, what I see initially is I see a giant wavetable, and then I see commands like port C, DDR-C, and I think they do, TCCR1A, TCCR1B. These are the flags that define the microcontroller being manipulated within the Arduino IDE. Because this IDE is perfectly capable of doing that kind of work. It doesn't have to, and it shouldn't. It shouldn't. If you're doing a project for babies, it should be able to be read by babies. This isn't necessarily a project by babies. I think it's like a research project, but still, they didn't need to go to this level. We're going to see if we can dig it out of the sand a little bit here and sort of reveal the simplicity of what this thing is really doing, right? Oh, the hovercrafts are coming by. Normal IDEs they use for normal microcontrollers are super complicated. I've tried to set up 1 or 2 in my day, and it's been just pulling hair. You need to be like a computer engineer to do it. All right, so what we're going to do is we're going to do a brand new project, right? And typically with something like this, I would love to take elements of this project and pull it over into my own programming in order to build up the entire body of the program. I don't think we're going to have that luxury today. I don't think we're going to have that luxury today because this code is just so convoluted that I don't think there's anything that I want to use in it. So here's where we're going to start. I'm going to go through and I'm going to leave a header like that, just the big text blocks. The date today is September the 8th in the year 2020, the year 2000. $2,025 of the Lord. Okay. Ultrasonic emitter array with some buttons and a laser pointer that manipulates a 40 kilohertz square wave, and it's out of phase buddy. I hope. Peens. What are peens? I really hate the compile, download, run cycle with micros. I love me crisp. The bootloader is nice. The bootloader is basically a, oh, is it August? I don't know why. This is Augustus. The cycle with the microcontroller and the bootloader, the typical like microcontroller writing, you'd be using like SPI, and it would have to write the whole entire microcontroller's code to it. And again, you could brick it if you set the flags wrong. And there's something exciting about that, but hooking up and hooking all those pins up and getting all that to run it's a hassle, especially when you're rapidly prototyping. If you have a bootloader, you can use a transmit and receive pin in order to load code into the microcontroller and get serial outputs from the microcontroller. So that's the good part about the bootloader. Bootloader basically looks at your code, and when you reset the Arduino, looks and sees whether or not there's a block of valid code waiting to be executed, and moves that block of code into its executable memory. I use Raspberry Pi Pico for all my projects now. You just write the code directly and REPL. We were doing that for a while for Burn the Subs, and I can see the appeal of that. It's just when I'm physically computing, I like to be lighter than a Raspberry Pi. I like to have this little guy instead. I just prefer it. But yeah, so we load the code on here using TX and RX. With this version of Arduino, it's not readable code. With MicroPython, some of those more powerful microcontrollers can just have readable code on them, which is crazy because then you can download the code off of the microcontroller. Now we can download the code off of the microcontroller, but it's going to be a bunch of like ASCII characters that we really can't understand because it's machine instructions for the micro. Compilers are sort of black magic devices that do stuff with your code that's sort of unholy and ends up rendering it into microcontroller executable code, depending on the micro you're using. And so you want to leave things universal enough that if you want to swap out microcontrollers, you blow up your last Arduino and all you have is a alternate weird Arduino, you can still load up your code and it'll still run fine. Sometimes, quote unquote, engineers violate that, and it really bugs me because whole like modular synthesizer platforms have been bricked for half a year because the microcontroller is no longer available due to the pandemic and the original creator switched. It's very annoying when they do stuff like that. But okay. Anyway, we don't need to worry about the nuts and bolts of how this thing works. We need to worry about how our specific program is going to interact with the real world. So I want to make some notes about what is connected where. So buttons on pin, well, micro. So that's according to how we wired this thing. Lord knows, I don't remember what the hell I wired. Talk about parallax. So that would be buttons on pins 4, 3, and well, it's 2, 3, and like something else. Why did I commit this to memory? There's no way that I would be able to remember this by the time I get back to the damn thing. I guess we could just ohm it out. We could just ohm it out. Use the multimeter, ohm it out, and then I can say exactly where everybody's connected. And we also have the parts, the wiring diagram from the project itself that we've mostly followed. Mostly. Now, having an MS Paint document that would just tell me what's connected where probably would have been a good idea, but I didn't do that. Game. This doesn't have a diagram in it. No, this is the supplementary information. This one has kind of an okay diagram. Or no, it doesn't. Where's the diagram? All right, come on. There's a whole family of devices. That was literally the one we were just looking at. How dumb. That song is going to be stuck in my head. So I don't know what's up with Chrome. It keeps turning off AdBlock Plus. I need to switch over. I think it's been like subtly turning off the ad blocker. And so the entire... Yeah, the internet's just useless. Okay, this is the right one. So this is what I hooked up. Close to this. Can we get closer in on that? I need to like open it in a new window so I can zoom way the hell in. Okay, 2, 3, and 4, but I think we have 2, 3, and like D5 or something like that. So let's just make sure what's connected where. And that is done with the multimeter and my probes. What's Ladybird? I've never heard of that. Powerful and very available, support till 2040. For the RPi, you mean like the Pico? I got a couple Picos that I've been using on stuff. They're pretty good. Is that ground? That's ground right there. That's ground. Okay. And so that would mean that the... Which row is it? Is it this one? Yeah, so whichever one that's on. That seems a little close. The second pin in on the left. Pin 8. So, button, wrong one. Buttons. Okay. Little box of stuff on the keyboard. Left, D8. Middle goes to, I think, 4. Check that real quick. Ground, and then this one to four, and then the next one to 3. To 3. To 3? What? Huh? This one here. This one here. 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 Dear God. What have I done? Let's go above. Levitation Megacorp does not buy them off. Yeah, I've switched to Firefox on the other computer. I just haven't on this one. Okay, what did it, ground is here. One of these should be this button unless we forgot to wire it up. I may have forgotten to wire up the button. Let's not put it past my personal ability to hook things up. No, no, no. Also no. That was a predictable no. And these aren't pins that I should be using. Did I not hook up an entire button? Oh my God. Okay, well, I guess that's means for me to be pulling this thing off again. Certainly didn't connect it on the other side of the board. So we've already found like a little mistake in our physical building of the circuit. By little mistake, I mean a great, giant, heaving mistake. Because this bank over here is not connected to anything. Double check, 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 triple check, double check, double check, double check, double check, double check. I'm out of pins. Okay, all right. So we didn't wire up one of the buttons. Okay, so that means just to finish our thought here, middle should be D4 and right should be D3. Then we have motor controller. And we've wired it up exactly the same as this, as this, as this. And I just want to jot down those pins so that while we're programming, I don't have to worry about anything. So A0 to N1. We'll just use a semicolon. A1 and 2. Is that how it works? 0, 1, 1, 2, 3, etc. Nice and confusing. We don't need this old program. We're not going to use that at all. No. Open this here. A2, M3, A4, oops, 3, and 4. Okay, and then laser, transistor, D question mark, because we haven't hooked it up yet. We haven't hooked that up yet. And then LED, switch, LED, D question mark, D question mark. And then just the direction for red and the direction for green. Yeah, this was made for a PhD project, so the code is incredibly cursed. Is that every single physical pin that the microcontroller is utilizing? I believe it is. I think we've run out of features. We've got the middle left and right button. We have a laser output that I haven't figured out yet with a transistor on it. We have N1 through 4, and then we have power going in and out to everybody. Not of the code. Of the theory of what the code is doing, yes. But nothing explaining why they did the code the way they did it. Maybe if I dig a little bit more, but I didn't do that much digging. I didn't dig very far, and it seemed like they were hiding it. All right, so that's all of our pinouts. There's a little bit of physical wiring that we could do in order to get the rest of our hardware working. But instead of worrying about that, I simply just have notes on it. And we will be able to incorporate stuff into the code that we want. Now we get down to this thing, brass tacks. We can actually program the microcontroller itself to do stuff. I can't believe that that third button is not hooked up. To do left button. And then transistor with laser, 5 volts. Let's put that on another line. Okay, so that's basically it. What I like to do is I like to give the date. I did it in an obnoxious way. I should probably do it in a more clear way. Then I give a description of what the project is on sort of a basic level that I'll be able to read and go, why did I try to be snarky? But it also explains that everything that's actually going to happen on this project. And then I give the pinout of the physical board that I've built in order to operate the damn thing. And then at the bottom, sometimes I give notes. Sometimes up here, I'll give a theory of operation. In this case, we're hoping to make it simple enough that it's not going to confuse the bother from a year and a half from now that has to read this. PhD students rarely publish their code. Interesting. The code that we got is just cursed. You're supposed to just load it up onto the microcontroller. Oh, and then pins. I think it's D10 and 11. Double check. For sync, apparently, in order to sync up the timing of everything, 2 of the pins of the microcontroller, D10 and D11, are wired together. We might not even use that. We might not have to use that depending on how our square wave generator is going to work in this thing. I don't know if the Teensy audio tools can be run in anything but a Teensy 3 point whatever, right? I think the Paul Stoffrigan Teensy tools, which would be perfect for running this thing, I don't think they work outside of that specific microcontroller. Not sure. I think I read something about it, but I don't remember what I read. Either way, making a square wave with an Arduino is a very common thing. We're not going to start with that. That's going to be the challenge, is trying to find... I pray for future Bother's mental health. It'll be okay. No, we'll get through this. Making a square wave with an Arduino is such a common thing that I think we should be able to breeze through it. I think that should be a very easy thing to do. What I want to do right now is set up the skeleton of our program. I want to set up the framework that's going to carry the rest of everything through. So the first thing we need is to deal with the buttons. What are we going to do with the buttons? Well, in terms of the organization of an Arduino program, I mean, you're basically going to have your big categories of things, and the way that it works is you have a setup and you have a loop. So initially, I'm going to initialize a bunch of stuff in sort of universal code space, in the global variable space, which is this area right here, before our loop, before our setup. That initializes the things in our microcontroller that need to be there, like global variables. Pin assignments I like to do right up at the top of the program, just so that if we change pins, I don't have to dive into multiple functions and stuff like that. We have setup, which runs one singular time. Each line of this code that goes into these brackets executes once. So it's good for setting up things that are just going to stay the way they are throughout the duration of the program running. Loop runs over and over again. You get stuck in the loop and you continue doing stuff in the program. Now this is objective, so what you're able to do is you can use functions. You can say, do the thing here as one of the things that happens with this program. Do the thing is currently completely undefined. Some IDEs will yell at you. You're supposed to put those things up here so that those functions get defined before they get called on in the code. But this IDE is smart enough, and I appreciate the organization of below the loop, you have all of your functions. So I would have void, which is a return on the program. If I wanted to have something calculated up here, and I wanted to return like a variable, I could make that return something. Void doesn't return anything, it just executes the instructions. So void, do the thing, and then more curly braces. And what this will do is this will organize the different sections of your program into what they're supposed to do. This is sort of the way to make your microcontroller code much more readable, especially in the Arduino space. I have a broad category of main things that I want the microcontroller to do. Do this thing, do that thing, do the other thing, do the other thing, right? And so I'll just put those functions in my loop. I won't put any calculations. I won't put any numbers anywhere in my code. There's numbers of no place in any code that's below the setup. I will define numbers as variables up here, and then in the future, I can change them easily by going through the variables up top. And that's kind of how we organize these microcontroller projects like this. So the first thing I want is to operate the buttons. So I'm going to pull up an example. The library that I like to use for buttons is called Bounce2. Bounce2 has a bunch of good examples on it. Let's open up one of them. We basically go through this list of libraries that we've installed in our microcontroller library, and we look for an example. This is examples for Teensy 4.0. Examples for any board, built-in examples. Somewhere down here, examples from custom libraries. So down here, we've got Bounce2. And then there's a bunch of different ones here. So bounce button, bounce basic, and then there's more. Current duration, previous duration, bounce more, bounce two, change, and retrigger. I guess I want bounce button because I want to see an example of multiple things. Yeah, the big steps in the main and give them descriptive names that are going to inform the future dumb person who's reading your code how it functions overall. So define button pin. This isn't even including bounce, is it? No, there it is. Include bounce too. Why do they put it so far down? Generally, I like to put the includes up at the very top of the program, above the notes. Kind of a weird place for them. Maybe we can put it below the notes for this one. Just have a block of includes, and then I'll give a commented line and just say pin out, or rather pin assignments. Down here, I'm actually going to put the same thing in front of setup. That's just so I can find it again. Other IDEs have ways to organize this stuff. I like doing this because it catches my eye as I'm scrolling by. All right, so pins. How are we doing this? We don't need to LED pin on this. And then I guess this is a bouncers. Bounce to button, button equals bounce to button. What? Huh? I don't know, maybe bounce 2 wasn't the one that I used. We'll try it. So in the setup, we do button attach. Button attach, and we have 3 buttons. We'll change that. I'm just copying it to have it in there because we need 3 different bouncers. We don't need to include it 3 times. And then in the pins, we need to define button pin R center and left. Actually, let's get, well, having pin in there helps define it as button pin. BR, B center, B left. And let's get rid of this. A little clunky. And those, according to up here, left is pin 8. Middle is 4. Right is 2. Okay, there. What does the double quote mean? It's attaching, ooh man. It's about what's being attached to what. Bounce to button, and it would be like button R, C, and L. And then R, C, and L. Pin BR. I think I'm doing this right. Correct me if I'm wrong. Maybe we need to look at an example to figure this out. Pin BC. Pin BL. I gotta remind myself of what the double quotes means, because or the double colon. Oh yeah, I'm doing resistor, inductor, capacitor. You're right. So we're speaking C language. It's better if we put Arduino in front of it. Arduino double semicolon. Dot and double colon. Double colon, I think, attaches the thing to it. These are both method calls. One uses a period and the other uses a double colon. For my own routines, the IDE, it's the period notation. What's with that? It's something to do with the hodgepodge of Arduino language. C++ serial is an object, an instance of class hardware serial. So we are defining the instance of the class bounce to and putting it on button. And then when we call button class, we can call the property of the class using button.interval, because that's attached to button, which is a bounce to object. That's how I understand it. I don't know if that explains it at all. in the library, a bounce to object thingy is given all these properties, and so we want to access this property for 3 different ones. So we are attaching it. Oh, you know what? It might be button. This might be. Wait, I'm probably doing this completely wrong, aren't I? Let's look up multiple buttons and see if I can suss that out. Let's see if we can figure this out. So examples, and then down to, I might be using it wrong. My own explanation has already confused me. Bounce to, TWO. I'm not going to use AI. We're not using AI today. You always suggest that I just fuck off and use AI to answer my questions. No, we figure things out the real way. That way we know we're getting good information. They're calling it in a completely different way, and I think I'm going to alter my code in order to do so the same, because I've done this in the past. Yeah, they're just using a different programming parlance. So none of this colon crap. I'll probably have to redo that, but I don't know why they did it 2 different ways. It's so weird. Bounce 1, bounce 2, bounce 3, and this would be bounce R, bouncer, bounce C, and bounce left. So bounce is equal to bounce thingy bounce. The bounce, bounce, wiggle, bounce. Define, and then we have pin button right, button center, button left. And then this one is assigning input pull up to them. So we'll do pin modes. So we got 1. Nope, what are you doing? And then pin BR, pin BC, pin BL. This is how I like programming. It's a lot more straightforward. We basically have our defines for the pins. we assign our bouncers, our 3 bouncers, and then we set a pin mode for the 3 pins, and then we attach the different modes to each one. So dot attach is being used correctly there with the right input. I don't need all of these spaces in here because I am able to read language that isn't spaced out completely. I don't know why some people make it take up the entire page. Just a tool for these questions. See, can I backseat code? Yes, you can backseat code. I may or may not use your backseat code, but you are allowed to chip in if you would like, especially if I'm, getting something wrong because we had to just look something up. Look, you gotta understand, you are your most vulnerable when you don't know the answer to the question, right? You don't know the answer to the question. You don't have the foundation of knowledge that's going to build up a proper answer to the question. That's the state that I'm in when we look something up on the internet. That's why I hate using AI for it, because AI will tell you whatever's agreeable and acceptable, because all it wants to get is a right answer criteria on its response as per the language that it's using. So it wants to be agreeable, it wants to be nice, it wants to tell you you're smart, and it wants to get the right answer. Whereas if I Google it, I can be called an idiot 8 ways to Sunday, and I can get the right information and why my question was stupid to begin with. This is important information when you're trying to build a foundation of knowledge, or when you're trying to repeat knowledge that you should already know. So I do not trust AI in that sense. I'm never going to look something up on AI if I don't, or I'm never going to look up something on AI because you already need to know the answer. You already need to know the answer to know that it's not just lying to you. That's weird. Pin mode. I guess they pin mode, debouncer, and then interval. So button interval. So in the bouncer, well, let's just make a settings section. So settings section, define bounce B time. Yeah, B time is going to be like maybe 8, we'll do 8 for the time being. So, and then now we need to actually do the bounce.interval. So it's going to be button R interval B time. We're not going to need 3 different B times. That's RLC. I mean, RCL. Okay, so we've done a whole lot of waffling about, and we may not have gotten anything done. Oh, violation. They have numbers inside of the code. Horrible. Set the LED. We don't need to do that. I mean, I guess we could do LED built-in as well. But then we're gonna have to set up all of our different pins in here later on when we get to that. Right now, we're going through and we're setting up the buttons. I only want to set up the buttons and what they do. We won't be able to verify this code, but it goes in so simply that it should be able to be implemented fairly easily in order to make the skeleton of our code that's going to make up the rest of our program. We can make them all toggle the LED. We'll do that. We'll have it check the state of the LED. So we'll have the LED state. So we're going to do a variable glue balls. And then this will be a, I mean, we don't need to, we're not pinching memory right now. I could make this an integer, and the amount of space that an integer takes up is infinitesimal compared to anything else that we'd be doing in this program. But I could also just make it a Boolean. LED state is equal to 0. 0. And then when we initialize, what I'm going to do is I'm going to set up pin mode LED built-in output digital writes. LED built-in is a built-in function for recent, not recent, it's been there for a while. It basically means that in the microcontroller definition files, they tell you that pin 13 or pin 4, whatever pin they decide should be the board's internal status LED. That's called LED built-in now. It's kind of a weird feature. It just basically takes a number and associates a number with LED built-in. Low. Well, actually, it should be high to indicate that we are done with setup. And then we don't touch the LED state there because we initialized it as a Boolean true. 1, 0, true, false, low, high are all interchangeable. And I'll interchange between them depending on my mood or if I just want to annoy people. Yeah, that's what they're doing here. So debouncer 1 and 2. So we need to individually update our debouncers. So on our loop, jump scare, light mode jump scare. Instead of writing 3 lines of code, I am going to save myself so much time by just writing update bounce. And then I'm going to go down here and in my functions, I'm going to do void update bounce. In there, I have the 3 functions. Why would you do that? You're not saving yourself anything bother. Anybody with the right mind would look at those 3 lines of code and go, I know what those are there for, it's fine. Well, you know, good habits, I guess. Good habits, I guess. A Boolean is literally just 1 bit. You can't preserve memory more than that. I'm saying the scenario in which I need to do a Boolean instead of an int on an ATmega328 only exists in the mega fringes of the absolute min-maxing hellscape of the ATmega328, the whole project sphere. The times that I would need it, I would have to have so many like fixed blocks of matrices or something in there that it's insane. A passive aggressive, yeah, that's what those 3 defines are. High, low, 1, 0, true, false. LED right, true is just annoying enough to make the hair on the back of a programmer's head just stand a little bit on edge, and I love that. I love that for them, that they would be so pedantic that something like that would annoy them. So I tried to do that a lot. I try to do that a lot. So anyway, update the bouncers, that runs every loop. So that's a major tenet of the program. It's a major thing that the program's doing. It wants to update all of its buttons to make sure that the user hasn't pressed one. Okay, so then value 1 equals low, value 2, they are debouncer.read. So there's a different way that we can do this that I've done in the past, and I don't remember what it was. Let's take a look at the examples. There's a better way to do this with the loops, or at least according to me. Update bounce, it's like if, but then we have 3 variables. We don't have like 1 variable to mean anything has changed. So I could do this giant loop and see whether or not, well, I'll do stuff. Do button stuff. Do button stuff. So that's going to check to see if any button stuff has been done. Right there. And then what I'm going to do is I'm going to actually write a little description here and just do checks to see if button stuff has been done, runs the whatever it is, the callbacks. Is that how that works? I don't know if this one does callbacks. Some of them, sometimes you have like interrupt callbacks where if a button's pressed, it'll do the thing, the callback of the button. I don't know if button 2 does that. I'm not sure if you set up callbacks in this one or if it just, because you can have them interrupt your whole program when something happens. I kind of prefer the buttons to work that way because it's a lot easier to know what your program is doing. Nope, doesn't look like it. Okay, so this one doesn't work on callbacks because it's meant for like 1 thread. You can kind of get into trouble with your singular thread getting derailed by button presses because you don't know where to return to from when your subroutine is done being done by the button. So this is just for one single debouncer. Yeah, bounce debouncer. So I got to do this but 3 times, huh? Okay, so we can do checks the LED variable and toggles. So void LED toggle, and then it's basically an if LED state is true, then LED state is equal to false. Oh wait, no. Digital write, oh yeah, LED state equal to 0, digital write. So this is the business of actually writing the pin. LED built in, that's all caps. Built in low. And then else, so we catch everything else. LED state is equal to 1. And then digital write LED built-in high. If you really want to get cursed with your code, you could do like LED state plus plus, and this could be LED state minus minus, and that'll just get you mad in the future. That'll just get you mad in the future. You assume that the Boolean state is manipulable by pluses and minuses. We'll just definitively set it to the 0 and 1. So if I run LED toggle, that's going to reverse the LED and then log it to LED state, which is my beautiful variable up here. LED state, yeah, is equal to 1 because we digital write LED built-in high right here. And then we go through the loop, we update the bounce to update just the basic bouncers. And then we do button stuff here. And so if, and then let's see, going to the other code. If button R update. Now, wait a minute. What is it? Wait, there's like falling and rising edge. Button release state 0. I had a more advanced button thing. I don't remember this being so rudimentary. I remember we were able to actually use like the rising and falling states of the buttons and stuff. We had like a good debounce button going on here. We had a good thing going, Walter. Bounce current duration, previous duration, blink toggle, bounce more, bounce 2, change and re-trigger. I don't know, none of these examples seem like the one that I like. What happened to the one that I like? Maybe that was just original bounce, or maybe we found a different bounce too. Attach button pin, interval, update, debouncer.fell. That's what I want. I want, actually, do I want fell is when you push the button and you attach it to ground. So when you push that button, something changes. And I guess what 25 does is gives it a huge amount of time before it will register a fall. But it also does, I don't know if it's rise or rose. We can look inside of the program and see what there is, or maybe we can just look up bounce 2. Let's look up the bounce 2 properties. Bounce 2. The bouncer and then bounce. Class links to the bouncer class to hardware pin on your board. It's oddly named because it needs to be backwards compatible for easy versions of the library. Is there one property that can check all three buttons? That's what I'm wondering too. Attach interval, set press state. If button dot press to do something. This should be, yeah, here we go. Set press state, bool state. We don't need to do that. Although press state, yeah, that could be a good one, but is pressed, released. Get pin, interval, previous duration, current duration, changed, read, fell, rows. There we go. Changed, read, fell, rows. So if rows, and then that function is going to return true if the button raises up. So when we press the button, nothing happens. When we release it, oh, wait a minute, no, fell. We want fell. Sorry, everything is opposite. Everything is opposite because we're using normally open switches with input pull-ups. Just put big capacitors in the button pins. No, this is beyond that. I'm trying to get the actual function of the buttons. This is beyond that. This is beyond just the capacitor. You can just attach a capacitor and that'll debalance your button because you need to charge the capacitor. And so in the microsecond interval, when you're bouncing against the spring of the button, when you're bouncing on your boy's button, it will toggle back and forth, and this just ensures, you know, you charge a capacitor during that interval until it can finally do what it needs to do. In this case, we're using a digital debouncer, so it's actually going to use the timing of the microcontroller to make sure that everything's honky-dory. This may also complicate our square wave ambitions. We may have trouble with the square wave because of this. If button R fell, if button L fell, well, button C, then button L. So we're going to check all three individually. Some idiot could come in here and mess up all the controls all at once, and I guess that would be okay too. But yeah. So if any of these three are on their falling edge, then we are going to do LED toggle with one L, two Gs. So we just simply run LED toggle. And they're all the same. Obviously, if you do something repetitiously in programming, you should probably be, especially in object-oriented C type programming, if you do something repetitiously, you should probably take a step back and go, wait a minute, I can rewrite this to not be so repetitious. Now, I like doing this in my microcontroller programs because I like everything to be super minimalistic. Some people, Hajiwo, for instance, not to badmouth a fairly awesome and successful YouTuber that does some amazing modular synthesizer work. The programming is much more complicated than what we're doing here. But what Hajiwo does is takes big pieces of code and just cobbles them together and gets them to work. And that may be 10 million times more efficient. He probably burns out a lot less than I do. Probably has much more success in life as a result of doing things that way. I can't live with myself doing things that way. I need to boil things down to their component parts and sort of know how everybody's interacting with everybody and have sort of minimalistic microcontroller code. That's where I live. That's what I like to do. Sorry. But that's what we're doing here. We are setting up so that I can build this up later. In the event where, this would be something that I'd write in the final program, I may think of doing button R fell or button L or button, use an or an and or whatever. Needs to be elegant, bro. That's right. Come on. I can't abide by weird, because he'll have like functions that aren't being used in this particular program because it's part of like a synthesizer workshop program that's being sort of bent into a modular synth. He had wavetables that would be formed every single loop, like it would make a whole new wavetable, which is crazy, but I guess the loops are slower than what's being sent to the A to D to make an external signal. So like while it performs that loop, the A to D is using big pieces of that wavetable in order to poop out that wave. It's a whole thing about like timing and speeds in microcontrollers. It's insane. It just feels so wasteful to me. But it stems from the program doing something else previously in a previous life. I need to schedule an expensive visit to the dentist. I've been brushing my teeth very regularly because they've started to hurt a little bit up where the root canal was performed before. There were some areas that the teeth were looking like to be kind of cavity-y. So I'm going to have an expensive dental visit soon. Fun times. There'll be more delays on streams, huh? Just what I need. The other thing is if I've just got one line of code in each of these loops, I kind of like to compact them a little bit. That's maybe not going to be the case in the future. Actually, it might be the case in the future. So I can just make this compact within the Arduino IDE, and it's just a little bit less of a visual burden. This is, of course, not necessary in any way, shape, or sense, because the IDE just gets rid of all the excess lines for me when I compile code. But in this case, do button stuff, we've only got 3 buttons, and those are going to run their own individual button operator, because I think the 3 buttons are going to be up, down, and then activate or deactivate the laser. As to replace the tooth with a cold one, I need a cap put on a crown right now. I had a crown done, it was extremely uncomfortable, and so I need to get a cap. It'll probably be titanium, but they need to like scan you and like get it made somewhere, I think. It's very strange. Okay, our test program is ready to go. So we kind of waffled around a little bit, and I hopefully taught you guys a thing or two about organizing and building up your microcontroller program. Because if you don't do things like this, you end up with a weird PhD program that we were looking at before. Here, hold on, it's this one. You end up with this weird organization of code that's kind of hard to navigate. And the newer IDE is, I think, a little bit more compatible with expanding blocks of code and stuff, so you can really kind of simplify what you're working on and keep focused, because otherwise you get this weird stuff where there's no explanation block. We input sleep and power for some reason, end ports and end divs 1 and 24. This is already some kind of math function. Then we have wait mid lit, output wave pointer D, port C. There's 2 things here. What's going on? Button sense 2500, end frames 24. And then we just jump into an animation with end frames. Our setup is almost all commented out except for the microcontroller resets. 80 CSRA, disable everything that we don't need in the microcontroller. This is crazy. Yeah, but this is before the day of computer-generated code. It seems like they took out all of the niceties of it, and they used like a waveform generator program and took out everything they don't need from that. Any button pressed, plus button counter. Button counter is greater than button sense. Button counter is equal to 0, but if it's not pressed, it's like an array. Like, this is crazy. So yeah, being overly clever with your program and stuff like that. The only challenge that I see is with running the bounce library. Bounce might do stuff that we don't want to take up our time if our timing is going to be severe. If we're going to be really stringent about our time. If performing microcontroller cycles is going to cause an interruption or a square wave. We'll look up some square wave libraries. We will look up some square wave libraries and see which ones have the right features for us. That's going to be important for avoiding delays in this code. But first things first, we got to see where we forgot to put semicolons. So what I'm going to do is I'm going to define my board, and I'm going to get my programmer. The 3 buttons we'll just use a piece of wire for. One of the advantages of the Arduino, again, is that the programmer is going to power our circuit. if it's as minimalistic as just the microcontroller, which we will start with because I don't want to just start putting waves into, 12 volt power devices. So I need this thing. This is the 3 volt programmer. So we were using some kind of Tasmota stuff with a, no. Tasmota stuff with a pin header. Now this is an old microcontroller. The whole point of doing this project is that we were using an old piece of equipment to power this thing so that I can use it up. This is used for programming Tasmota home devices, which are 3 volt. So I have this old FTDI programmer. Originally, this is a whole explanation. The Arduino Atmega 328 was a through-hole device. It was a big prototyping board, and you didn't necessarily have, no, you did. You had a USB hookup directly on that. Back in the day, we didn't have microcontrollers that could communicate fast enough to communicate properly on USB. We didn't have direct USB inputs to microcontrollers. Along came a company called FTDI, and they made a chip that was $14 because they had this proprietary chip that would easily allow us to plug USB into the chip, and the chip would act as a virtual COM port. So we had TX and RX capability, COM port stuff, going into the Arduino chip, and that way the bootloader could communicate in TX and RX 5 volt on and off signals back to us, and we could communicate to it. There was a lot of cool stuff that you could actually do with that two-way communication. Nowadays, it's direct USB to board because FTDI, tooth and nail, hung on to their $14 chips. There are some Chinese knockoff versions of this, and again, my nephew who got that home sensor device kit, man, that thing was, I'm kind of mad at that thing because it had a lot of cool sensors on it, had some servo stuff. It had a knockoff Arduino. The knockoff Arduino had the knockoff FTDI, and the instructions were not good enough to get the proper drivers. So I had to spend about a half an hour guiding him through the process. He's lucky he has like a complete expert in that, guiding him through the process of installing drivers for the weird knockoff Arduino chip. FTDI, Windows just has drivers for those, but the weird knockoff, it doesn't. So you have to go through the whole thing. And that's where a lot of people slip up and they go, this is stupid. I don't want to mess with microcontrollers anymore because they have to do stuff with drivers, and you're not supposed to have to do that. With the Arduino family of devices, you should be able to just plug it into the computer and then tell the UI what Arduino you're using. Everything works. So he had to go through the whole process of finding drivers, and that's what we used to have to do anyway. We used to have to do all that stuff, and it was this unfortunate barrier of entry to getting into physical computing. The FTDI SparkFun thing with the Pro Mini was meant to sever the $14 board from the microcontroller board. So you bought $20 microcontroller boards and another $20 for the programmer, and you could jump this thing between projects. We're using these up. This is obsolete. All of the chips now, they take USB directly in, or they've got some other form of FTDI that somebody has custom come up with on a much cheaper microcontroller. So I need to find my other programming board, the 5 volt one. Here it is. Yeah, and I can put the 3 volt one away. Yeah, it is just an unfortunate thing. We're past those days. But he bought this kit from Micro Center and it was kind of old. All right, so what pins are what on this thing? This is a knockoff Pro Mini, so the pinout is weird. DTR, TXO. I love how SparkFun decided to add a letter to RX and TX. And it just made everything more confusing. So we want this the other way around. Why is it ground, raw, ground? I guess they didn't label, no, that pin's labeled ground, but yeah. So this actually plugs in upside down because the knockoff is stupid. Because the knockoff is stupid, this thing plugs in upside down, so we won't be able to observe our TX and RX through those LEDs over there. This is an old busted Arduino, so hopefully we still work. Yeah, FTDI is probably still relevant to some systems, maybe older systems, but not to this one. Okay, so we've plugged in. I have not plugged in USB yet. I will do that in a moment. But first, hold on, I'll just plug in USB right now. So I'll just plug this into, I've got this little satellite USB plug over here. It's the old Valve wireless adapter. Plug that in. So the LED on the Arduino is on. Let's bring the hold on, spring arm in here. Go. You drop that below me. Oh my God, 3 mares! How dare you show me Taco Bell ads? 73 months, 3 mares. Thank you so much. Thank you. 73 months and a Taco Bell ad. Yeah, the ad block situation has gotten bad. Hold on, where are you guys? Where is my... There it is. This one is the one I want to move. We're all bunched up in the corner today. Bring myself down and over a little bit. There, now you got enough view of the desk. Yeah, the ad situation on Twitch has gotten kind of bad, hasn't it? Whatever this thing was programmed with before has already initialized itself, according to the way that I normally write code. Getting ads everywhere. You can kind of, you need to run a couple different commands to kind of bend Chrome's arm back behind its back, and there's some crackling noises that it makes that can enable you to allow ad block, like uBlock Origin, to run again on Chrome, or switch to Firefox, which is what I did on most of my stuff on the stream computer. Because of the plugin that I use for chat, I still have it running, what is it? Those weird functions that enable AdBlock Plus to actually run, but it periodically gets just disabled by Chrome. Like the settings are like bounced again remotely. It is obnoxious. I just moved to Firefox and everything's okay except YouTube takes a ton of time to load, which is very, very annoying. Okay, so we don't have our code in here yet. This thing came on. We know what it is. Ads on YouTube have gone crazy. Got to the point where I removed their app and didn't watch it. There's like YouTube Vanced or something like that. Yeah, using the apps for YouTube and stuff. Yeah, it's gotten bad. There's still ways to get around it, and I vehemently despise ads. That's why I love Twitch. Is because Twitch used to be a program, used to be an application, used to be a platform where you would pay the person directly. And that was the whole thing about it. You pay them directly and Twitch would scrape a bunch of the money off of the top. But apparently that's not good enough for them. That's not good enough for them. They decided because number goes up, they had to continue to basically string out our patience to the very end of it. The board that we want an Arduino AVR board. We want the Arduino Pro or Pro Mini over here. Select that. It's going to change some of the options in the tool menu. We've got the Atmega 328, 5 volts, 16 megahertz. That's just the standard one. And I typically would buy the 5 volts one in the past because I sometimes use old electronics that use 5 volts instead of 3 volts. And I do have some 3 volt Atmega 328s. How do you tell which one it is? Well, technically on the board, the development board, they should have it marked. They didn't mark a goddamn thing because these are like cheap rip-offs. Atmega 328P, AU 1429. None of that appears to indicate what the voltage is. I could look at this voltage regulator and see what the voltage is. What was that noise? Was that just me shifting in my... Yeah, that was just me shifting in my stool. I thought I heard the dog. The dog does not come down to visit me anymore. She appreciates quiet in the afternoons. So we get no more corgi visits down here, which is very sad for me, but it's fine. She has her preferences. Okay, so I have no confirmation what the voltage of this thing is. I have a feeling it's 5 volts. Just in case, I'm going to check the VCC pin. So just put this thing over to volts since we got the multimeter out anyway. I'm just going to make sure that I'm not, well, actually the thing would have died by now because I'm giving it 5 volts already. So this thing would have been dead, I think. I don't know if the programmer goes through the voltage regulator. Oh, turn it on. Okay, yeah, so it is 5 volts. I typically will buy the 5-volt ones because sometimes I have older stuff that needs 5 volts in order to function. Okay, so what we're gonna do is load our code up. Now we have basically done a hello world, but instead it's 3 buttons. So 3 buttons we're gonna load up into this thing. So I hit upload, it's gonna check, oh well, I have to save it as something. So I'm gonna actually put this in a different folder. It's gonna be the desktop. I haven't been able to program get stuff into my file server because of permissions issues. So I've made a folder on the desktop. The tried and true way to store all of your sensitive projects is just a folder on the desktop. And then that would be the stream project. And then do I have just module tester, mixpad, keypad revision, channel point, fart, solenoid skeleton. That's I think the right one, but it's not. Oh no, this is different. No, that's different. So this one's actually going to be a new project, and that's one's levitator. It's called levitation. There we go. So levitation now is a program name, and I've hit upload on it already. It's going to save it. I don't know if it's going to automatically. Okay, checked it over. Compiling. Hey, none of that. Button R was not declared within this scope. Oh my God. Button R dot fell. Button R dot fell was not declared within the scope. Oh my God. Button R attach, button R interval. I'm using it incorrectly in here. Button R dot fell. Okay. Fell, rose, read. Read would actually read the pin state. But I would like to know whether or not it fell. So I guess maybe I can't run it within the loop like this. Did I spell something wrong? Button R. No. So let's see. Button R interval, button R attach, pin mode, pin mode, pin mode. Update the buttons. Button R interval B time. Wait, that's update bounce. Oh, shouldn't be interval. This one should be update. And it does not need the time in there. No need for that. Okay, so that's actually the correct thing. We're finding all kinds of mistakes. What's my volume like? Okay, I'm good. We just are losing people to the boringness of programming, which is typical. Well, let's see if that checks out now that we've got the update in there. I think it'll still catch it. Yeah, not declared within the scope, huh? So they're updating it into a variable, and then they're checking against the variable. Oh, update. Yeah, did I get that right? Update. Yeah, it updates. But if this is in a different, but that should be global. Because we attach the pins, we give it the interval, and we're declaring them out here. One of these days we'll get more than a fart. I don't know what else you think it's. Wait a minute, more than a fart? I don't want that. I don't want anything to do with that. Oh, what could it be? I'm sure programmers are like gnashing their teeth. You guys are welcome to chime in. Not declared within the scope. I guess I can't put if this as a true. Instead, I could put it out to a variable and check it 3 times, right? I could locally define a variable. I just thought that was kind of clunky when I could just run the routine and whatever the return on that routine is, button r.fel is true or false. $53, $54. Equals bounce r. Where was our example? That's up here. Oh, well, it's bounce, debouncer, bounce, and then debouncer dot interval attach, etc. Changed is equal to debouncer dot update. So debouncer dot fel, I think it should work in that scope, but I'm wrong. That should work. I think it's complaining about the instance. How so, do you mean? Dot fel. Maybe it doesn't like fel. I don't know. Try rows. Rows should probably return the same thing, though. Unless I need to give it different context, or... That's probably not going to get by. I don't need a semicolon in there. Oh. Bounce R, but button R. Oh, I see what you mean. I get what you mean. These should be changed to button. I don't know why it didn't catch that any sooner. RCNL, and then button, 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 button. It's funny that it got to that first. Let's try that. Good catch. Good catch, chat. You guys were wrong. You were always wrong. What's wrong with you? You guys fucked this up for the last time. You absolute fucking nincompoops. All right, pin mode is capitalized. Check again for errors. No, you guys are absolutely right. It got further along. You guys are completely correct. Go, go, go. Okay, so we're using 4% of program memory and 2% of dynamic memory. You can see that we are on the bleeding edge of what this microcontroller is capable of. Let's upload to it, and then we can bounce a couple pins around and see the LED turn on and off. An error has occurred while trying to upload the sketch. What the? Can't open. Oh, we didn't choose the port. Tools, port. We have COM4 and we have COM6. If I unplug the programmer, oh, that's not unplugging. Unplug the programmer from USB. USB, is it COM4 or COM6 that we lose? We lost COM6. So this is coming in on COM port number 6 as a virtual COM port ready for data. Careful, my head will get too big. Tools, port, COM6. Upload that shiz. So no mistakes in the code. Everybody works properly. We used all the right variable names. And now our code gets uploaded into the Arduino. We get this nice little blinking lights display that we can't see over here. And then this thing did some weird stuff and then turned off. And on and off and on and on and off. Okay, hi, it's me, the program that's doing weird stuff. What's going on? Why are we on, off, on, off? Oh, are these in a constant state of rows? Fel. but it shouldn't toggle it constantly while in that state. We're looking for the transition. That's the important part about it. And we have input pull-up, and our variable starts as a 1 because it's input pull-up. LED built-in starts high. So when we update our buttons, there shouldn't be constant raising and falling messages. Something is awry. Let's try uploading it again and see if it's just in a more stable state. I know, the one's for update, I know. It might be that our interval is so small that noise is getting through. Let's up the interval above 5. Or what do we have it at? We have like 10. 8. Bring it up to 25 and just see what happens. Because technically this is how it should normally sit. It should be sitting on input pull-ups. So why would this be doing crazy stuff? And the input pull-up pin, I think, is pin 13. Oh, unless it's pin 8. Wait a minute. What are you hooked up to? I don't know what the internal pin is on. So if I go to ground, and I go to 3 or 4, push the button, pin 4, pin 8. All right, well, pin 8 kind of works once. Pin 4, pin 3. What the heck's going on here? My very simple button mashing program is not functioning in the way that I think it should. These are not supposed to be touch buttons, and they're not supposed to toggle like this. Hello? Resetting. That's a good trick. We declare them as input pull-up, to my knowledge. Let's check. Input pull-up. Pins are 2, 4, and 8. Two, 4. So this should be fairly simple, but some weird is going on. And is it due to my programming? I don't think it's noise out here, but when I do add a bunch of noise, it does toggle it weird. Wow, this is weird. 25 should be plenty of time. Oh, this should be pin 3. The initial LED state is 1 for high. And then digital write LED built-in high. Unless the built-in LED is on a different pin or something, but I'm only acting on 1 pin, so. And the built-in LED, let's just double check. Arduino Pro Mini built-in LED. Pin 13. Now, if I really need to do like high-level debugging, not high-level, low-level debugging, I could put in a serial print line because we are powering the circuit through the computer. We are always connected to serial at this point. And so we could put in a little serial print in order to give us a little idea of what's going on. But our program is so simple. It basically just comes down and looks to see whether or not a button's been pressed. I mean, I could turn this into an else if, and then that way it's not individually operating these every loop. That might clean it up a little bit. Oh, we should check the Pro Mini allows internal pull-ups. I think it does allow internal pull-ups. I don't see any reason why it wouldn't. We've done that before. Looks kind of stable. Did that, wait. Oh, okay. So now it just turns it off and leaves it off. Buddy, come on. You're making me into a weirdo. Reset it. LED's on. Hit a button. Turns off. Hit the same button. Stays off. Why? Let's see. Because if the button fell toggle, LED toggle, if the LED state is 1, if this is true, we set it to 0. But we shouldn't be coming through and saying it fell every single time. Fell should be a singular operation of the transition from one state to the next, right? So what did I not do properly here? Update, update, update. If the right fell, if the center fell, if the left fell, toggle. So when we release the button, it'll hit toggle. If the state is 0, as in low, if the state is, sorry, if the LED state is true, high, 1, then it sets it 0, sets it low. Otherwise, we can assume that it's low and it gets set high. And this is an else, so it only checks it once. It doesn't like check it again and, you know, rewrite it with a different value. That's what you got to be careful with some of these. Is if they're not else ifs, then it can change a state and then alter that state, especially when you have a singular variable doing the work on this. So if the LED state is low, then it skips this and it does this and it sets it high. If the LED state is high, then this is true and it does this, and the else is then skipped. So therefore, I am right, you are wrong, and this should function, but it doesn't. To the best of my knowledge, there's no reason why this thing, when I connect this like this, boop, it shouldn't turn that LED on. This is baffling. I am baffled. You can do LED state is equal to not LED state, digital write, LED built in, not LEDs. I'm not doing that. Why would I do that? That's so much more confusing. I'm writing it out in individual lines that are just a little bit less weird and compact than that. But why would I? No, that would be too confusing. The not state would just invert the Boolean, so it would be LED state not equals or not. Is that what you can do? I don't know how is equal to not LED state, but I'm not gonna do. I don't want to do that. It's fine. This should be fine. It's just I don't know what's going on with it. The bouncer is being a little finicky. If I set it to be faster, that shouldn't really affect it unless it's. I mean, the hardware is janky because I've got a piece of wire that I'm using instead of the LED, but this should smooth that over just fine. Pin mode, button attach with the button time, LED built-in output, LED built-in high, pin mode, input pull-up, Pro Mini, Is the Pro Mini not compatible with input pull-up? Connectors, there's two versions, 3.3 and 5 volt 16. Pro Mini is designed and manufactured by SparkFun. At Mega 328p input. Okay. Topic closed. I just want a verification that I can use it on this. Today I learned shopping on Lenovo gets you great deals. By the way, September's coming up, everybody. Okay, we just check if the pins have 5 volts on them. So from ground to pin 8. Huh. I don't see nothing. Hold on, let's try this way. Plot thickens. Pin 4. Ah. Do we not have input pull-up? Oh. Okay, so the behavior that I saw was consistent with a floating pin. Yeah, see, we got half a volt on the pin because it's just floating. And while I can connect it to ground, it's not doing anything. So if I did VCC, and then ground, and then I do VCC, and then I do ground, there we go. See, it works consistently. So apparently we do not have input pull-ups. Yeah, at least on this microcontroller, this rip-off Atmega 328, we do not have input pull-ups, so I need to go in here. I'll need to put like 10K resistors on each of the pins, pulling them up to VCC. Harder to do on this breadboard. I didn't expect to have to do this. So in this program, I'm going to come up here and do each button needs an input pull-up. Sad face. Input pull-ups save you a whole lot of trouble, and it's very annoying that these don't have it. I really thought that we would be able to do that. Demonstrate input pull-up with pin mode, monitor state, blah, blah, blah. I guess maybe certain ones don't have it, like the older ones. Try to make a controller box. Nope. Sadly, tried to connect the buttons. The Arduino Pro Micro didn't recognize being pressed. Output works, same port, but with input pull-up, it does not. Okay, this is a different problem. This is a different problem. I feel like the newer ones probably have it working. 86 in my room. I'm dying and my motivation is at an all-time low. Go get a frosty drink. The input pull-up is internal to the 328p, so it has to be on the Pro Mini. Maybe this specific flavor of Pro Mini just doesn't have it working, or did I type it wrong? I mean, it did highlight the syntax. We got to get rid of some of the extra windows that I've got open. They're getting confusing. This is a great program, by the way. I love this one because I used an OLED screen and I made nice, neat, and organized windows that do stuff. Very cool. We will get back to doing synthesizer stuff soon. I do apologize for not streaming for so long and, you know, for not getting a lot done each stream. I'm gonna retool and go back to the baby steps and try to like do stuff that everybody can relate to a little bit here and bring us through the sort of pantheon of projects that I've got going on. And, you know, we're going to build up functionality as we go in the same way that I've been doing this whole time that people don't give me credit for. They come in here and they say, where's Burn the Subs? Why haven't you done anything on it? Well, I've done 500 different things that have had sort of a satellite functionality that I need to refine within my own capabilities in order to realize Burn the Subs and get that to fruition. But I'm glad you could drop in and belittle me for one comment and then leave forever. People do that, and it really gets me, it really nettles, you know, I get nettled about that. Yeah, I was away for 1 week. It is a long time in terms of streamer mode. Streamer mode, I should be streaming every day. I should be doing a daily stream. Then you get in all the algorithms, which is just a very annoying way to live life. I do 3 times a week, which is the absolute minimum. Maybe I should be going a little bit harder into the paint. Yeah, so it is all caps. Oh, that's, sorry, that's that, but input pull-up I think is also all caps. Yeah, see, it doesn't highlight. I'm not doing nothing wrong. Wait, when this gets attached, wait a minute. Trixie code. Trixie code. Trying to flip me up. Trying to flip me around. Trying to get me rotated. You can't rotate me. I'm an apex predator. You can't get me rotated. I don't know how to read. Oh, wait a minute. Got to get through the oxidation. Wasn't pin 8 declared very specifically? I don't think I declared pin 9. It might be that certain pins can do input pull-up. Like 3 and 4 can do it? Why is there nothing on 4? What the deuce? Okay, so let's just see. Pin 8, doot. Yeah, okay, double doots. 4, doot. 3, doot. All semblance of instability has vanished before my very eyes. Father, what was that? Why did you have a sudden epiphany? Why was all of this that way? Because I'm dumb. This routine, when you... okay, sorry, hold on. This routine here, when you button dot attach, it asks for what the input type is, and that should have indicated to me that it is running the pin mode command on its own. So when I just called these inputs, what it did is it switched it from input pull-up to input, and so the microcontroller turned off its internal transistor and swapped them into floating pins. And when a pin floats, if you saw me tap it to VCC and tap it to ground to verify that it was working, I was looking at the troubleshooting step of figuring out how it was working. And my internal troubleshooting thing said, look, this LED is turning on and off and on and off. I don't see voltage on the pin. So it's not being toggled as an input pull-up. So maybe the microcontroller doesn't have that function. So I went and looked online. I found dog shit online because that's online. Didn't find any definitive answers that way. Came back over here, took a good long look at it and said, well, if I attach VCC and then I attach ground, it functions in the way that I think it should. it's actually clocking that transition, but then it gets noise and it starts clocking some weird stuff. We upped the interval. It wasn't the interval. Finally, looking at this, because the behavior was of it not having the input pull-up feature. And so finally, I don't know, I was just looking down on the code, and it's like, wait a minute, why are these being declared as an input and not input pull-up there? So the examples that we had conflicting styles of coding of this stuff, and so I ended up putting in a block of declarations of input pull-ups, and then below it, I negated that by attaching the buttons to it without them there. Now, the solution in the end, if I didn't figure that out, would have been to put a couple 10K resistors on those pins and run the other side of that 10K resistor to VCC. That's all I would need to do. That would create the pull-up scenario where if I push the button, it then goes to ground. Yeah, doing 8 a.m. to like late at night, Monday to Saturday. Some people maintain those schedules, but they do other stuff. They'll like leave, like go take a shower and just leave their stream on and stuff. I don't think I could ever do that. We really kind of utilize our brains here, and our brains are not very good at marathons. Maybe someday in the near future I could do a marathon stream, but today is not, that is not these days. My brain has been steadily turning into mush. I've turned around a couple different habits that I have, and hopefully they will be working for my greater good. I'm gonna lose some weight. I'm gonna feel a little bit better about being attentive. Leaving this chat alone for 5 minutes sounds like chaos and potential dance. We're actually, I don't jinx me on this, but we're pretty well behaved here. We're like any given like Sark chat or not, maybe Rabaz. Rabaz gets kind of a little rowdy around politics, but generally we're all kind of in it together. I don't see you guys getting into too bad of arguments. It's usually the typical nerd ego kind of argument where it's like, I know what I said and I'm right. And then the other person goes, no, but there's a corner case that's totally weird. And no, but that doesn't matter. Back and forth. It's a typical nerd argument kind of thing. But you guys usually you figure it out pretty quickly. Chat would somehow build a no. Without me here, it's everybody just leaves. Okay, so we've successfully attached our 3 bounces. We've got 3 separate functionalities happening within our program in sort of an uninterrupting fashion. So if and then I guess I could turn these into ifs as well. They might be a little bit conflicting, but this routine will only run once, so we can get rid of the else ifs on this. The else here is okay. I guess we can keep it. It's a little sort of iron-fisted, but I don't think it'll ever get out of scope. So we have made the dumb framework that's going to power the rest of this program. The third, well, this one would be, instead of LED toggle, it would be laser toggle, and we can just flip that over to do the job of being the laser. Now I don't know what pin I'm connecting to that yet, so we'll just keep this with the LEDs. The next thing that we need to do is the second piece of functionality from this levitation station. What's your nation? So now we need to actually produce a 40 kilohertz output square wave, and we need to see how messing with the buttons and the LEDs are going to interact with that and get it working. This is still in the realm of relatively simple things. Let's just verify what the signals should look like on the output of our actual project. That's the switch that we got that somehow magically just figured out what switch that was. That's a special switch. I don't know if I should save it for something. I guess it's fine working here. I can use that LED to indicate like a state of things. I don't know. What can I do with the bicolor LED of this thing? We might swap this switch out for a different one. This one might be a little bit too fancy for this project, because it's got the bicolor LED in the switch itself. This thing would be better on something synthesizer related where I use it once and it has like kind of a cool indicator to it. Okay, clean up, because we're moving over to a different library. I'll actually save this. Should I download it? Yeah, save as. We'll just throw it in there for now. I wonder how much these cost these days. Data key, maybe. Push button switches. $11. Holy. $10 for one of these things. Holy hell. They got 100 of them in stock. Jesus. I mean, if they weren't right angle, I could certainly put more of them in series with one another. You could make a pretty cool like switchboard with them. $10 a switch is steep. Like if I was making a 1 or a 2 HP module, I could maybe put these and the plugs on. Nah, I don't know. That's expensive. All right, close that. Let's not look at that ever again. I do kind of want to save that in my back pocket in case I ever want a special one. Yeah, you got to make like thousands of the device. All right, so here is one of the papers on this, one of the instructions on this, and this goes into a lot more detail about how they derived all their stuff, right? Pressure force module, P0 is the amplitude, blah, 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 blah. This is sort of the detail one. Is that what we need? Here they're evaluating stuff. This is, okay, transducer response. 20 volt peak to peak, 40 kilohertz sinusoidal excitation signal generated with a single generator and B output from the transducer measured with a microphone. What the excitation signal from the driver and output of the transistor. The yellow line is the signal in the time domain, sine wave. And the purple line in the frequency domain with the 40 kilohertz at the center frequency, 200 kilohertz span. That's all they tell me. Schematic of the driving circuit. The main components are an Arduino Nano and a motor driver, L278N. It can generate 2 driving signals, and the relative phase is controlled by connecting ground to D2 or D3 in the Arduino Nano. D4 resets the starting position. So the relative phase of one square wave to the next. Or is it the sine wave? Are they outputting a sine wave? 20 volt peak to peak, 40 kilohertz sinusoidal excitation signal generated with a signal generator. What are the L278N? Images we want to pin out. Maybe a data sheet. Full bridge rectum driver. All right. 0 input voltage up to 1.5. High noise community. Blah, blah, blah. Integrated monolithic. They're always monolithic. 15 lead multi-watt power SO package. To enable inputs. 2 enable inputs are provided to enable or disable the device independently. We've got our outputs and our inputs and our H bridge and our logic. In 1, in 2. Enable A, enable B. So the enables are permanently enabled. They have jumpers on them. So enable, enable. And we've got in 1, 2, 3, and 4. What does the signal need to look like coming out of this thing? Not math. No, we're doing not math. We don't have to do math. What's my glucose level doing? 155. Look at how much better that is. I had a smaller lunch because I wasn't hungry. And yeah, pretty cool. That is, by the way, up-to-date glucose levels. It's 5 minutes with a 5-minute delay. So about 5 minutes ago, my glucose level was 155 milligrams per deciliter of blood. So full bridge and an AND gate. Oh, AND is the enable. I see. So AND is the enable. So in 2 and in 1. In 1, not to 1, positive, whatever. So it'll be opposites to out 1, opposites to out 2. So we want a sinusoidal wave. How's it? Wait. Okay. Well, maybe the paper will lay it out for us a little bit more easily. Where's the paper? Papers, please. Sound is a mechanical wave. Welcome to sound. Okay, close that. Oh, we have so many different instances of this thing open right now, just because it was a pretty intense research session. I don't need any of these anymore. I don't need this anymore. Don't need my basics of buttons 101, though maybe I will later on. It's funny, we didn't detect the input pull-up on the multimeter, but I think I just wasn't hitting the probes properly. Voltage for level, different voltage for different samples. After 19 peak to peak, the predictions do not fit the simulation. See, they get lost in voltages. They don't tell me exactly what's coming out of the pins. And then we've got datasheet for the LM98 or whatever. Didn't give me a ton of information here. It feels kind of like it should be a square wave on this thing. But if they're making a sine wave, then do we need to have between input 1 and input 2? Wait a minute, where's that logic? In 1 goes to both of these. Oh, I see, because it's 2 full bridge rectifiers. I see. So that would mean that you would want in 1 and in 2 would be the opposite of one another. Because then we'd have out 1 and out 2 would be connected to positive and negative associated with it. So out 1 to A and B, out 2 to these two down here. I say A and B, but it's, wait, A and B is not up there. So it would be like 1 and 0, and then 0 and 1. How would you make that? Is that what the wave table's in there for? Is it because we need to actually output a sine wave from the pin? Or like the equivalent of a sine wave? Wait, this is in... recent. This one. It takes a minute to open a file. I'm trying to figure out what the output of this thing is so that we can mimic it properly in our code and actually code it up to be understandable as opposed to this. And actually what I think I can do right now is I can just port COM6 at Mega328 and then I can just upload it and we can take a look at what's happening on those pins. Why don't we just do it that way? Yeah, to drive motors with the L298N, you need to use a square wave. I think maybe what they're doing is varying the square waves. They might have that kind of a wavetable thing going on. I don't know. Let's find out. Let's just upload this code. Let's put it on this micro and see what kind of crap it spits out at us. And then we're going to need probes. We're going to need 4 times the detail. Where are my probes? Where are my probes? They ended up over here. Yeah. Okay. So let's get channel 1 probe out. Channel 1, channel 1, channel 2, channel 1, channel 2. Channel 1 probe, and then I need the probe hat, which is just as valuable as the probe itself. Probe hats are precious, and they are to be kept no matter what. These are the first thing that is lost with any of these little pieces of kit. Nowadays, though, the thing that I love about the electronics hobby is that it's so ubiquitous that you can buy this hardware anywhere, or equivalent of this hardware. Didn't used to be like that. You used to have to fight other engineers to the death in order to keep this stuff from ending up in their coffee cup. It was a mad world out there. So let me get that focused. Let's get the scope on the screen. No, that didn't work. Ah, scope button doesn't work. Okay, so frame scope do I have? I'm still getting into my system here. Hold on. Studio mode. Great value branded. Look, it's better than nothing. You need to, like, the scope hat is a really important accessory when you're doing a clean breadboard setup, because you can clip it to the wire, right? That's super important. If you just have the pokey end, you can technically like wedge it in there. And I've seen some cursed stuff happen with these probes and breadboards, but this is just so much cleaner and hands off. You basically want your setup here, your lab setup, you want to be able to let go of it, right? So that you can go do something else. You don't want to have to sit here and hold everything up. So I'm going to connect my ground here like this. And then let me just get the scope on the screen here. Oh, I don't have a framed scope scene. I see. All right, so we'll just do frameless scope. Why do you not work? Hold on. Let me see. One sec. Oh, there it is. Oh, and it's got a frame around it. Huh. I guess I added a frame at some point. The edges need to be a little bit more curvy, though. Filters. Stroke. Let's see. Outer stroke, padding none. Stroke size. Offset fill type. Where's it? Is it shadow that's doing that? No. There's no way. Padding none. Blur type triangular. That's for the blur. That's the little drop shadow it has. Whoa! No, that's not right. Oh my god. That's not right either. Oh, it's padding. Okay, there we go. No, it's not. Oh no, that's padding him out. Hold on, one sec. That ain't do it. Inner stroke. No, I'm gonna screw up all my settings. I'm gonna hit. Oh no, I can't hit. Can't do that. Can't undo it. Hold on. I'm just trying to get rounded edges, and I don't know if this is the right thing. Because that outer outline, what's... Oh, wait, no. Let me just take a look at this. Frame thermals. Filters. Oh, advanced mask. Oh, I see. Okay, so we'll just do this quickly, add to the filter, and we'll do plus an advanced mask to that. And then the mask effect is it rectangle? I don't know. Oh, I forgot about all this stuff. But it needs to be applied sooner. There we go. See, I've got to get the center right, the center properly in, and the middle properly in. And then I need to expand it to where it lowers that size on both. Sorry, this is stuff that I should do on my own. Maybe I'll unapply. Let me just unapply all the filters, and we'll just raw dog this thing. I'll put a shadow on it. Okay, so we're looking at the old code. And so I've got one of my probes hooked up there, and the other one we can actually look at the wave output of this thing. Now that ground is looking mighty crazy. I don't know why it looks like that. It's 1x versus 10x. Oh, because they zoom us in way far on this scope. I need to do my settings a little better than that. We're zoomed way in. We need to be up here at like 6 volts at the top. And we're not dealing with modular synthesizers, so we actually don't need this to be all the way up there. We can move this like that, and then we've got a slightly higher range. Why is this moving at such a fine pitch? That's going to drive me crazy. Ugh, forget that. Just go back to the center. I need to mess with my scope settings. I still haven't reconciled the fact that my scope is like $200 cheaper than when I bought it. Now, theoretically, out of some of these analogs, we should be getting an actual signal. So the actual outputs are supposedly what pins? N, A0, 1, 2, and 3. So A0 should be giving us some kind of an output. This should be as simple as it gets in terms of scoping things. Oops. So I am going to open up time. I do not see anything going on. Why would that be? Now it took the code, it took the programming. I'll hit reset and just check again. It's doing nothing. A0, A1, A2, and A3. Check my probe settings. Why am I not pulling up the window? There we go. Display is on. Fine is off. Scale is 2 volt. Everything else is default. That should be good. Okay. This thing should be absolutely screaming an output right now, unless there's some kind of a button condition that I didn't know about ahead of time. Maybe if I take another jumper to ground and I hit A0 to 4, 2 to 4, A3, nothing. Now here's the thing, like, we got this project working, so we didn't do crazy microcontroller stuff with the previous version of this. We were able to just see this thing function with the Atmega 328, with the high frequency, with all the stuff that it does doing. And I don't think there's any huge differences between this rip-off Pro Micro and what we're using. These are definitely connected to ground. I've got the ground thing connected there. That's in like that. 1x mode or 10x mode. We're in 1x mode right now, which makes it a little bit more sensitive. And so all things considered, we should probably be seeing this thing screaming out a square wave. Let's double check. What's going on over here? Yeah, so that fully uploaded with the wavetable. Hey, Niano, how's it going? Hey, I mean, I know it disabled a bunch of stuff within the Arduino to get performance out of the chip, but something ain't doing. I don't think. Do we need a pull-up on the pin that we're observing? I don't think so. This thing certainly doesn't. It's a logic input, so as such, this should be 0 and 5 volts. We should be seeing a square wave here, right? Total power dissipation, peak output current, blah, 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 blah. Input enable version. 0.3 to 7 volts. So if I'm seeing nothing on the pin, it's not because there needs to be some kind of an input pull-up on it. Like if it already has something. They immediately talk about the transducers. They don't really go over the individual design of anything going on here. This is the most information that we get. Why do I smell electronics? Oh, nothing's on fire. Yeah, this is totally fine. I don't understand. Channel 1's hooked up. We've definitely got like signal coming through. We can see my 60 hertz. Move the trigger up. Maybe we can trigger off of a slightly higher signal here. Yeah, move the trigger up to like above 0.3. Zoom way out. I mean, it's 40 kilohertz. This should absolutely be shown by now. Very strange. If I reset, do we get anything? No junk noise? Nothing. See like a blip of information on that. And I'm looking at A0 right now. Let's get A3. A2. I have no reason to believe that the A0s and 1s and 2s and 3s would be any different for this one than its predecessors, the other types of Arduinos. So, and code set it loaded in fully, and it's on the right COM port, and it's set to 5 volts, 16 megahertz. That's just AC noise getting in. Probably from my microphone, you guys could probably hear some buzzing as I touch weird stuff on the desk. So, what's going on? Where's my square wave, buddy? This is your code, although there are no notes on any of the codes, so who the hell knows? Port C, pin mode 10 and 11, so that's the sync. Oh, there's no sync going on. Oh, that's what it is. Okay, so pin 10 and 11, I need to actually jumper to one another. Dun, dun, dun. Okay, so let's get that in there. Power this down for now. So 10 and 11 need a jumper in order to synchronize themselves. We were getting stuck in an infinite loop. Stuck in a loop. Troubleshooting. It's like a muscle that you have to exercise. Give me fake code. No, watch. It'll now come to life. Oh my God. Yep, there it is. Beautiful. So it is a square wave. It is just very simply put a 40 kilohertz square wave. Let's check what the adjacent channels look like by plugging in another probe. Channel 2, go! You can see the interference of the square wave on the adjacent channel before I hook it up. All right, so now I need a jumper. Do I have a jumper? I have no jumper. I gotta have like a stray one sitting around somewhere, right? No, they all got away. They all got put away or thrown away or cursed and tossed. Okay, we'll get this one. Actually, wait, we can this other ground jumper here. And we'll go to an adjacent channel, so A0 to A1. Whoa, my God, is it not using A0? 2, A3. What's this one? Okay, so it's the A1, 2. Or no, 0 to 1. 0 to 1 is yellow to blue. What the? There you go. So these are exactly out of phase with each other. And they're supposed to be very tightly kept. Yeah, I thought it would be a weird PWM, but I guess they were saying in the paper that this specific square wave makes it so that the drivers produce a sine wave. I guess that's just what happens. It's as you know, you give it all that energy, and then it sort of pushes the wavefront forward, and as it does that, that resembles a sinusoidal wave as a result. That's my understanding of it. So then the adjacent two are going to be doing the same thing, right? Except are they in phase? These are in phase, and these are out of phase. And then I don't have jumpers for it, but if I activate the button, the phases of these two are going to sort of wander away from each other. Oh, our trigger's weird. There we go. Lock it in. Lock in that trigger. Oh, and then maybe make the waveforms a little larger on the screen, because it's kind of silly to have them be so small. That's noisy because it's getting its ground from elsewhere, and we are in higher frequencies. Typically, we'll do audio stuff here. And so things like this will come through a lot cleaner. But yeah, so here's the two waveforms that it's creating at 40, all right, at 40 kilohertz. That's all it needs to do. So if we can get our code to do this, we'll be Gucci. Let's see what happens if I hit the buttons. Push the button. Is it A4? No, try A3 or D3. Yeah, there you go. See what it's doing? D3 changes the phase of one waveform to the other, which will allow us to move stuff up and down. So, and then this one resets it. No, wait a minute. This way, this way. Reset. Cool. All right, so that all functions. I mean, honestly, I could load this code up and it would do just fine. We have a couple modifications that we want to do to the code, though, to make it run on this thing so that we can understand how it's running a little better, and I can manipulate it a bit more, and so the code doesn't look like ass like it does right now. So what I want to do, even though it is tempting because I could just literally hook this thing up as it is right now, and the buttons, so one of the buttons wouldn't quite do what we want it to do. Otherwise, things would work just fine. I just want to characterize this. So we have a 5-volt square wave, and it is 40 kilohertz. And then the other one fairly smoothly changes its, whatever it is, its phase in relation to the other one. Now, this is doing it using a sync pin so that it can sync up what the two pins' activities is, and everybody does their job at the same time. And it's using all kinds of weird, like, wave tables, and I don't know, man. It seems like a little bit much. I just want to know what the duty cycle... Well, that's 50-50 duty cycle. Okay, so 50-50 duty cycle square wave, and we need opposite square waves, and we need to mess around with the phase a little bit. So let's see if we can accomplish that with something that's not a bunch of TCCR port definitions. A cursed microcontroller shenanigans. I'm going to actually just make the other one dance while we code. There we go. Look at him go. Okay. Okay. I don't have the full thing in my head right now, so I shouldn't try to replicate it. Arduino waveform generator. No, Arduino square wave library. I may already have. Let's actually look to see what I already have. You shut the hell up, AI. I don't give a shit about you. 1 to 100. It's a question. That's not what I'm looking for. Okay, back over to here. Examples. We want custom library. We don't want Teensy, because Teensy has the audio tools associated with it, and the Teensy audio tools solve this problem. We could just make this code in 5 seconds with the Teensy audio tools, but they only work on Teensy's. So the Atmega 328P might not be able to run it. So let's see, debounce, digital input, pull up, tone keyboard. None of this is exactly what we're looking for. Tone keyboard, tone sounds interesting, but I don't know if that's what we're going to be going for here. So let's see, for any board, stepper motor, I don't think we're looking for stepper. Servo's a little different, but that is PWM or PCM for servos. We'll see what the example has us doing. I think this is just going to sweep the duty cycle. (2013) code. Right, this is my servo.write. I don't think this is the right thing. Go back to examples. Graphics library, timer, IRC, WebSockets, bounce, Dallas temperature, ESC, no. Fast LED, no. We don't need PID, we don't need Gerbil. Those are screens. LVGL, man, I remember all this stuff. Matrix LED, RF 24. No. Okay, none of that stuff. Basics, I don't know if they're going to be doing anything with specific. Teensy, of course, has its audio tools that I don't think we can use. Let's see here. Let's see, just, hold on. Atmega 328P. Where's the button? P. Yeah, 328P is of course going to be missing. Arduino Pro Mini square wave library. Function generator, Arduino Pro Mini. Red, blue, green LED. We've got a 9-volt battery, holy hell, and a $30 oscilloscope. Nice. Function generator with Arduino Pro Mini and a few components that are power on at start with a sawtooth of about 40 hertz and 5-volt peak to peak. Pressing the one-time SW Fun button changes it. This is not what we're looking for. Firmware Arduino Pro Mini is here and requires the library timer 1. What are you using? This is probably not the best way to do it. I should probably look on the library manager. Because yeah, you get things like questions and then people don't really have answers. Yeah, why don't you use something that's way out of scope? Okay. It's all just easily distracted debate. Let's try frequency sweep. Sketch, include library, manage libraries, and we'll just use that to browse libraries. It kind of cuts out a lot of the noise. Because I have this feeling. That there's a library. Now, if I switch to a Teensy right now, I could literally load this code up and I would have 4 or 5 lines of extra code, and then we would have exactly the output that we're getting from this thing. The library manager might take a calendar year to start up. But we'll take these shots in the dark and we'll see if we can get this thing running. I don't think I can use the audio library with the Atmega 328. What if you even need a library, as the Atmega has hardware PWM, so there's probably functionality in the base core. It's possible if I could use the TCCR command that they use in the other code, then I could override the PWM frequency and set it as a 50-50 duty cycle PWM output. That, I don't know what that would do with the phase of the two channels, if I'd need to do something weird like what they're doing in their weird code. I'm going to search square and none of you can stop me. My neck just snapped. I just heard a very loud pop in my brain. I'm gonna stand up for a bit so I can send those blood clots on over to my brain and just get it all over with. Woo, let's go stroke. Nope, no stroke, I'm good. Has it searched square, or is it still held up about the fact that it still exists and it is a very old version of the IDE? I need to update my IDE. This is a very old version. I tried it when the new IDE came out. Everybody said, you got to move over to the new IDE. You got to do it. Move over to the new IDE. Do it. Bother. What are you doing? I said, all right. So I downloaded it and installed it, and then it didn't open. So back I go to the old version. Here I am marching back to antiquity for a program that's never failed me. Did this look? Arduino library for the function generator, polynomial curves to give a data point, polynomial fit, geez, that sounds cool. DF robot, what the fuck robot? 89837 waveform generator. Damn, that sounds cool, but that's not what we're doing. Microcrystal RV, what? With I2C bus. Data visualization, kick math, no. Few simple mathematical calculations for use with arrays. Arduino library for wind measurement using ultrasonic sensors. Oh, that sounds cool as hell, but not really, that's not. 809833. Programmable waveform generator. No, we're not looking for hardware. Real-time clock. Metronome. Can I create a 40 kilohertz metronome? See, the thing is, those Stoffrigan audio tools make this operation so easy. And I wonder if they will work with anything else. Lightning detector library. Oh, that's such good news. I definitely want to get that chip at some point. I want to have the local lightning detection and plug that into all my MQTT stuff. Easy processing of analog signals. Signal conditioning, where analog input is to be analyzed. The tone library, perhaps. Let's take a look. Timers one for all. Oh, here's tone. There's tone, just in time. We had a buddy in college. His name was Tony. He was extremely clumsy. He would enter a room and he would leave no sooner than one thing would have been broken. Generate drums. I'm not looking for issues. Why did it take me right to the issues page? Produce square wave of specified frequency and 50% duty cycle on any Arduino pin. A duration can optionally be specified. Otherwise, the wave continues until stop is called. Pin can be connected to piezo buzzer or other annoying fucking thing. Be sure to try out ringtone text transfer and blah, 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 blah. Yeah, tone sounds exactly like what we need. Any pin, so let's go ahead and get tone. Wait, tone or tone library? Version 1.71. No version here. Tone library was last updated a million years ago. Tone was updated more 1+ years ago. Huh. It's like the same thing. Play a tone, frequency is hertz, duration, play continuously. Play non-blocking, once called play will return immediately. I need 2 tones, technically 4. Oh my God. Somewhere around CS8. C8. It's actually close to what we need. No, that's 4,000. I need 40. So this one tops out. Hmm. 31 hertz is, wait, that's 8-bit timer. Interesting. 65,537. So play only accepts unsigned integers for frequency. The maximum frequency that can be produced is 65,535. Okay, so we can get to 40 kilohertz there. What are you building? So this is an ultrasonic levitator, and it needs to have a tone that goes into a motor controller that does all of these piezoelectric elements and will enable us to levitate stuff between these 2 plates. Right now, we're trying to get the code running, which is kind of an important facet of this whole thing. There's a couple little hardware things that I need to deal with as well. So this is probably going to take a little longer than today's stream. Again, this is something that's so trivial to do on the platform that I use now, which is the Teensy platform. Teensy platform, just as expensive as all these things used to be, but it's so fast and capable that Paul Stoffrigan has these online tools where you can just turn one into a synthesizer. These Teensy audio tools, you can put together building blocks that will enable your thing to do what you want it to do, right? This is a previous project, but what I could do is just, I could have a square wave with the properties and have it controlled within the thing so easily. Yeah, it's something that's completely trivial on the outside. Like play, I don't know, where's that square wave? And then I could give it properties, delays, all kinds of stuff, right? There's just some amazing like audio tools that exist within this. Problem is the Teensy audio library, I don't think it works with the Atmega 328p. Let's see, audio connections and memory, audio adapter, Teensy audio, Atmega. Not on the page. Yeah, so I don't think I'm going to be able to get it to run on this chip. They typically will use the much faster Teensy platform. There's a different protocol. It's called I2C audio. That's similar to I2C, but it's specifically for running right and left channel audio. But I think we need to just find one of these square wave outputters and just push it up to 40 hertz. But the problem that I'm running into here is I'm looking at this library and I don't see anything that allows me to slightly alter the phase of the waveform. I2S, not I2C, and unrelated. It's unrelated because we're not using a data acquisition card. We don't have, or DAC or an ADC. We don't have anything like that, so we're not using I2S. The previous project, though, did, and so when I had the audio tools up on, we've got I2S sitting right here. So that's I2S output from the Teensy. This just helps you kind of set up the initial outputs for the, for the different pieces of the thing. Now, technically, I mean, I could come in here and I could find, PWM maybe. PWM's not really what we want. Not tone sweep either. Drum, wavetable, sine, high res. I mean, maybe we do want PWM. Maybe I'd want a bunch of PWM signals and to give them the properties that we would need in order to create that 40 kilohertz tone. Duty cycle is 50% where the control waveform is 0. PWM duty cycle nearly 0 to 100%. Functions, change the frequency. Amplitude, change the amplitude. So I'd have a single amplitude, put the frequency in there. Is there a phase delay? Play blah, 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 mixer amp. These are all output types and input types. We don't need those. I don't know. Would it be like it's not a wavetable thing. Oh, that's what it would be. It would be just the regular old waveform. Regular old waveform, and then you'd specify square, 50% duty cycle, and then down here, let's see, begin, frequency, amplitude, offset, that's a DC offset, phase angle. So you could just specify the phase angle within that. If I could get that function to work on an Atmega 328P, I would be just happy as a clam. But I don't think these audio tools are going to work with the hardware that I have. And I want to use the cheap, busted old microcontroller because I want this thing to go away. I want it to be permanently attached to a project where the next time I want to do something else with the project, I go, what the hell was this microcontroller? And I throw it away. So I don't want to mess with it anymore. It's had its stint in my shop as the golden child of all of my projects, and it's time for it to go. What if I look up waveform? Actually, because I don't think it outputs the waveform directly. Arduino Pro Mini waveform. Graphical waveform from printables. High frequency block wave? What the hell's that? I'm looking for something that's gonna operate in the background and not bother me. And I could change the TCC, I could change the register that changes the duty cycle, or the frequency rather, of the PWM. How would I reconcile phase? How would we do phase? Would it be a timing function before it starts the waveform? So if I start one waveform and then I wait a prescribed amount of time and then I start the other waveform, is that going to give me an offset? No, because it's using the universal wave timer. It's not going to care about that. Let's test. Before I jump into the tone library. So before I even give a crap about what any of the buttons are doing, I'm just going to come in here and do, we'll do, yeah, hold on, not here. Pin mode, A0, output, analog, right, A0, 50, is that the, hold on, I gotta relook up analog output. Arduino reference. This is one of the best pages that you can go to is the language reference. They seem to not want you to go here anymore because it's like hidden behind a bunch of links, but this is really the best way to just make sure you're not being dumb. So what I'm gonna do is burp. Okay, I'm done. And then I'm going to go and look at my functions here. There's a bunch of math functions that'll help you do some cool stuff. But what I'm really looking for is my analog write. Because analog write is not what you think it is. people thought analog, you know, historically, and me especially, would go through the reference say analog right. Oh, cool. I need a specific voltage output. Now, specific voltage outputs are for digital to analog converters, not for the Arduino or your microcontroller to typically do. It's kind of a little bit of a wasted channel if you do that. You can get an analog signal from a PWM sort of loosely. If you add like resistors and capacitors to the PWM, you can kind of do the Flappy Bird Sallen key filtering to it too, using a operational amplifier. But typically you don't have these analog outputs. That's a specialization that's for either audio specific or waveform generating specific equipment. If you're doing RF, holy shit, you're making a lot of waveforms at a lot of high frequencies for RF. RF is crazy and you're crazy for looking at it. Analog right generates a rectangular wave of the specific duty cycle until the next call to analog right. So you do not need to call pin mode to set the pin as the output before calling analog right. Okay. Analog RIT. Value, duty cycle between 0 and 255. Oh, so we want 144. 148? No. 147. 50% duty cycle. Delay. What is our default frequency? What is our frequency? There is not the word frequency anywhere on the page. All right, let's just write this initially and then we'll figure out, well, let's just give it just a random old delay, like 13 microseconds, and then analog right a 147. So let's just do this test and see. I think they're going to be wrong. I think they're going to be off. We may need a function, either create a function that has phase in mind for setting the pin high and low. Oh yeah, 127, sorry. It wouldn't have mattered so much. I would have been like, these look weird. Okay, so let's just put that onto the microcontroller. I'm gonna have to move the pins over too. So new code, who dis? What's it doing? It's still compiling? Using core Arduino. Yeah, it's uploading it right now. Too few arguments, huh? Oh. I knew that. Yeah, it's going to be a very slow waveform when it comes back in. So one will go away. I think one will come back. Okay, maybe not. So on A0 and A1. Well, that should be A0 and 1. Take it way out in time here. Nope, nothing. What aren't you doing? Analog right, A0 and A1. I am connected to pins A0 and A1. Why do you not show me a waveform? Well, that guy. Restart it. Nothing. Did they lie to me about pin mode A0 output pin mode A1 output? I think they lied to me. You do not need to declare output on analog right. Uh-huh. Nah, guess not. Guess that wasn't it. Massage the pins. So why am I not getting any output? Ooh, that was a big noise. Analog write A0 127, delay 13, analog write A1 127. That's in setup. There's no conditionals on that. That should just do it. Oh, they're not PWM capable pins. Ah, yes, okay. At Mega 328P, pin out. Pin out. Good enough. Spelled it close enough. Give me the big picture. There we go. Which one? Arduino pinouts in blue or purpley. So let's see. Around the vicinity of A1 and A0. Where's that? 86 and 7. 2, 3, 4, 5. Which ones? Where's the timer PWM? PC2 and 3? A0 and A1 are A2, 3, 4, 5. Zero and 1 supposedly. Oh, I see. Timer PWM is green. OCB2. So these don't have. This one isn't as clear as I think it could be. We want green. Green is all the way over here. 11, 10, 9, 7, 6, and 5. Let's do 6 and 5 and try that out. Wait, so then they hardware bit banged the analog pins in order to get that to work. Yeah. So let's go over to 6 and 5 because they're not doing anything else. And then change my probe ports. D5 and 6. Now, what I'm trying to prove out here right now and just show you guys is that the phase is not going to be affected by our delay. Both of our square waves are going to come in at exactly the same time because they're going to use the same timer. 5 and 6 are even the fastest PWM by default. Well, I mean, we're not going to be utilizing any of that. So let me click upload and then we'll get some screaming slow PWM values in from this thing. And we can see if one of them is 13 milliseconds delayed. I used an odd number so that it would be clear that they're both coming in on different ticks. They're not. They are in lockstep with one another. So you can see here that they're both being controlled by the same timing register, which is why, I guess why they bit banged it, why they used like a wavetable bit banging kind of style for the other code, for the code that, you know, works. This is complicating things a little bit, and maybe I need to do a calculation per time based on the microcontroller clock. That seems like a little bit much. Because if you do it calculating it, then you can put a delay in there and it'll delay it. But as of right now, that doesn't work. So our library needs to support that. I need that as a primary function because doing that can move the stuff in the air up and down. And I know you guys still don't get to see stuff float in the air. We'll get there. We're gonna get there. So this function sucks. Do we have any tone functions in the Arduino reference here? Bit set, bit clear, pin mode, analog I/O, trigonometry, external interrupts, interrupts, characters, advanced I/O, no tone. Stops the generation of square wave triggered by tone. Oh, okay. Why was that before tone? Oh, there's tone. Square wave at the specified frequency and 50% duty cycle on a pin. Duration can be specified, otherwise the wave continues until a call to no tone. The pin can be connected to a piezo buzzer on the other speaker to play tones. Only one tone can be generated at a time. You friggin' bastards. If a tone is already playing on a different pin, the call to tone will have no effect. What the fuck? This is stupid. Pin frequency, duration, and that's it. This sucks. What are the defaults on this thing? Pin. .40. Frequency and tone in hertz. Unsigned int. Duration, we're not going to leave it. We're just going to leave that alone. See if this blows up our Arduino. Tone uses the timer. We're about to find out. Or is it this one? There. There's a nice 40 kilohertz square wave. Looking good. I think it's 40 kilohertz. I mean, I'm not verifying it exactly. But the Arduino appears to be capable of actually outputting that. That's kind of neat. The challenge would then be creating a square wave that mimics that with a delay. I don't know how I would be able to do that because this doesn't work like that. It doesn't work like that. If I make the tone on one of the pins of the Arduino and then I have the logic look through to see whether it's high or low and mimic that, is that going to be fast enough? I don't think so. I don't think so. That would be a way to get multiple pins to sort of follow the logic of what's going on. Be like, okay, so for some reason the Amazon lady, the voice activated lady behind me, thought I was talking to her. Multiple tones. No, no, no. We're not trying to play multiple tones. What? Using 3, what is it, harmonizing? No, but they're calling no tone to turn off the tone. That's so weird. That's not what we need. We need a continuous waveform out of multiple different pins. What is the follower, the tone pitch follower? Analog read A00, print sensor reading. No, that's not what we're looking for. I mean, like, I don't know. I don't think this would be fast enough that if we put this 40 kilohertz tone into something and then we have it. No, we would need to use internal delays in order to do that. That's not a good way to do it. I mean, I could have a timer running and then have it go high and low for the whatever it's supposed to be defined as high and low on that timer, and then I can have timer plus variable to do the delay from 0 to whatever the 180 degree phase is. But I wanted to find a library that did this better, which I'm sure there is. We were looking at tone libraries a minute ago. None of them seem to have phase on it though, and the only place that I'm seeing phase is in the Paul Stoffrigan tools. Like, this has phase associated with the waveform. Yeah, they share timer 0. But if they don't share timer 0 and we go over to another timer, will we then get our phase delay in there? So if I do the Atmega 328 pin out, so you're saying timer PWM, OCCO A and B So pin 6 and 5, we can just go back. I mean, I really want it to be A0 and 1 and 2. That's because those were the original pins that I wired up, but I guess I could change it. Where's ADC 0? ADC 0. Which timer is it on? It doesn't specify. So if I do pin 6 and 5, let's just do, I don't know if that's at 40 kilohertz, that's going to come out anywhere. Here, let me just actually use the cursors on the oscilloscope to figure this out. So like a half a cycle is somewhere around delta y, delta x. It's like 5 microseconds, so delay microseconds. Did I spell that right? Very tiny delay. And then tone, pin 5, 40K. Upload. Change my leads. Go back to this view. Turn off the cursors. Wait for it to upload. The 5 and 6 share timer 0. Whoa, it didn't even create a wave on that one. What did I hit the button or something? Oh, maybe I hit this. Whoa, it's nasty. Kind of looks cool though. 5 and 6. 6 just can't keep up. With the tone command. Is that on a different pin that I don't know of? No. No. Huh. Well, okay, so I was going off of this pin diagram that I've got sitting over here. And OCCOA and OCC0A, oh, it's behind the thing. Yeah, you can't see it. OCC0A under timer / PWM, and then OCB0B. So they're different timers. But OCC0, should I be looking for OCC like 1? OCC 2? 0 and 2. Pin 3 we're got stuff assigned to right now. Yeah, I should probably look for a library to do this. I see, it's the comparator function. This is the nitty-gritty of the microcontrollers, the shared banks of functionality and stuff. It's possible that we could do this in a more bit-bangy way. You look like young Wozniak. I'm gonna start losing weight soon. I try to get myself out of that category. Woz is cool though. He's a cool guy. Doesn't afraid of anything. So 0A and 0B, same bank. All right, damn it. Stupid thing. This is why we're just playing with some base functionality just to see if I don't need an actual like timing library that does things in a weird way. But it seems like I'm going to need some kind of a tone library, and I would really prefer to have it able and capable of doing that delay, because we're going to need the output, we're going to need the inverse output, we're going to need the phase delay output and the phase delay inverse output. These are things that are really easy to do with other hardware, but doesn't want to become geography. What? You mean extremely stationary? Wait. People think Jobs didn't do any technical work are very wrong. That dude was probably more. Yeah, I mean, the dude is extremely smart and capable of making some kind of amazing things. But yeah. Okay, so tone, we're not going to do it with tone because the banks are all the same, and doing that micro delay in there means that I'm going to have to really shift the pinouts all around. I'm beginning to suspect that the table from the other code might be the most efficient way to get there. This is, I mean, listen, that's how PhD, projects work. They do things in the best way, but they don't tell you anything about that. We may be on a journey of discovery right back to where we started, but at least we will have flexed our programming muscles a little bit, and I'm able to create sort of a nice, neat framework of a program here that we can kind of occupy. I don't want to use the same method of wavetable generation and all that stuff. It's possible, excuse me, hold on. It's possible that the plugins that we install, whatever library we install, whatever specialty stupid thing we figure out and install into this thing, does it the same way. It's just under the hood. But yeah, let's see here. Tools, or no, examples. Analog, probably not what we're looking for. Communication, not quite what we're looking for. Basic kit, no, we're not looking for that. Fade. So somewhere in here, not the teensy specific ones. Mata, liquid crystal, SD card, servo, stepper, Tembu, and retired. Bridge and Explora. EEPROM stuff, nah. Graphics stuff, nah. I've already been through this a little bit. Yeah, so I think, oh, here's tone. Tone test. Apparently I've already got tone installed. Did I click install on tone? I don't think I did. Maybe I did click install and I don't remember. I don't think we've used tone for anything. Dueling tones, simultaneous tone generation. That sounds familiar. To mix the output of the signals to output to a small speaker, aka an 8 ohms or higher, simply use 1 kilo ohm resistors. This example plays notes A through G. Oh God, I don't want that. Set through the serial monitor. So include tone.h, and then we have the tone notes. Note player 0 and 1 begin on pins 11 and 12. If serial is available, character C is equal to read. Case of A to G, play basic notes. Note player of 0, play note. Example, tone. I must have installed it. DTMF test, oh geez. RTTTL. What's levitating? My bad, I'm new here. We're working on it. As soon as we can reproduce the output of the code that was provided with the levitation project, then I can actually levitate stuff. So it's probably gonna be next stream tomorrow when I'm able to actually levitate anything, and or I just give up and we use the code that was provided for us. I wanted to have a little bit more control of the code, and so we're looking up stuff with tone libraries to see if we can get the proper 40 kilohertz output from the microcontroller with a 40 kilohertz output and a slightly phase delayed 40 kilohertz output without using a massive wavetable. It's possible that I could put it up to an equation as per time, but yeah. RTTTL, while P, blah, 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 number. This is programmed in ConfusoVision. Whole note of 10, print BPM. So if I am to get tone to output the tone, oh my God, they have copyright music in here. This is all almost completely copywritten music here in sequences. Oh my God, The Simpsons. I don't want Fox International to sue me. Duran. Literally just 20th century. Okay, that's just. Please don't write me a letter. Please don't sue me. Cute, but geez. Okay, so yeah, let's get rid of this. So there's nothing really, so we're doing like more hardcore waveform stuff, and there's nothing really mentioning about phase offsets of tones. Dun, 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 da, 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 dun, da, da. Okay, anyway. Play it as a sad tune and then have somebody with a weird accent sing slowly over it. We're going to have it output a singular waveform, and that waveform needs to be in 40 kilohertz. This thing was made for audio, but it does go up to 65,535 kilohertz. So we need to go back to the tone library and figure out how in the world we're going to get it to do the weird thing that we want it to do. This is the wrong library. This is the Arduino. No, docs.arduino.cc. Functions tone. This is the OG tone. Yeah, tone multiple, PWM, tone melody. Wait, tone multiple. Plays a tone on each one of the speakers in sequence, turning off the previous speaker. That's stupid. That's stupid. Close this. And of course, the Teensy audio stuff would do this perfectly, but I don't want to switch over to a Teensy. Oh boy, explain like I'm 5. We've got an ultrasonic levitator, and we're looking for a way to make it work in software. And I'm looking at this tone library for Arduino right now and trying to get it to go up to 40 kilohertz. But the original project is a ultrasonic levitator or tractor beam, an audio tractor beam. You can just look up Instructables/acoustic-levitator. Which is what we're building. We got 90% of the thing built. I'm just being a fuddy-duddy about the software, because it's not up to spec for me. It's too complicated, it's too weird, it's too PhD-y. It may work rock solidly. I don't necessarily need to be rock solid. I just need it to make sense to me. Using the Paul Stoffrigan audio waveform tools, it would be trivial for me to lay this thing out and get it to work perfectly. With those tools, it's a much faster microcontroller. I'm trying to use up crap because my lab is full of crap. And so I'm trying to use this Atmega 328P in order to power it. It is perfectly capable of doing that. Perfectly capable. But we've got to mess around with some libraries in order to get that to run. So let's get the tone library outputting 2 tones on 2 of the analog pins over here. If I can use the analog pins, it means I don't have to rewire stuff. Let's see here. So we want 0 and 1. And then we're going to come over here and we are going to use the tone library. So I have to include tone. Include capitals, tone.h. Include tone h. Hey, tone h, how you doing? I like the challenge where Obother will end up just programming the timer and counter registers by hand because the library is crap. That makes it a whole lot similar to, I mean, this is still more complicated. If I could just TCCR and set up the timer on my own and somehow be able to give it that delay, I guess that would be acceptable. This is the example that comes with the Levitator project that you can just download, right? You can just download this. And you can just throw it onto the micro and it'll just run. But I wanted it to do some extra stuff, some extra different stuff for me. So, and they're doing some weird stuff. So what they're doing is they I don't know what these knops are. I don't know what the knops are in here. Wait lot A, wait mid A, wait lit A. And then they've got a waveform animation table. And then here they are going into the ports and redefining some stuff. I don't know, Smith Clay. I haven't been streaming in a little bit because family has been here. Knops are the calibrated weights. Ay. That's craziness. They are magic from measurement. Okay. Yeah, because here's where we're going in and fast PWM clear, fast PWM no prescaler. And it involves CPU calculations and stuff. This is like the hardcore microcontroller stuff that you should really only do if you've been backed into a corner. If you've been completely backed into a corner, then you can get into those timers and you can do stuff on the machine language level with them. Even using the Arduino IDE, it's very possible to do. And you know, all that capability is there, but microcontrollers are like ogres and they have feelings. And you don't want to hurt those feelings. No, they have layers to them, and you can peel back the layers until you are speaking machine language to the micro. It's the fastest way to do things, but shaving those hairs is not often necessary 99.999% of the time. I don't think it's necessary here either. Is microcontroller the same as Arduino? So that's a lot of explanation, but I'm willing to give it now because I've been backed into a corner. So the microcontroller has a specific brand, and that's the Atmega 328P on this board. If I were using a slightly different system, I could be using a variety of different microcontrollers and configurations. So when I say microcontroller, I mean the chip itself that's performing the instructions. When I say Arduino, I mean a suite of tools with an IDE, programming interface that can interface me with the Arduino using what's called a bootloader. Bootloader is a set of software that sits on the microcontroller hardware itself. It accepts transmitted data into it on like a TX and RX pin. It doesn't have to be TX and RX, it could be via USB, but the bootloader is there to take the new code into memory, take a look at it, say, okay, that code's okay, and then load it into the main instructions when the microcontroller resets. And it does that with a restart. This is instead of using a bunch of pins to actuate an actual memory like reprogramming on the microcontroller. So that way we can sit here and dumbly iterate through our code. Remember, they're not fuck ups, they're iterations in microcontroller. We iterate through code. We iterate things here, okay? We iterate our 3D prints and the iterations go in the garbage. That's how we do it scientifically. It's like holding a clipboard on a job site. Anyway, so we throw things into the bootloader and it executes that code and we can see the result of our dumbass reprogrammings and where the smoke comes from at the end. I do bare metal assembly language on an Atmega, but still use a bootloader. Blah, 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 blah. Can't believe you do. I guess if you do bare instructions, you can go down to the AT Tiny like 10 and you have like 4 pins to use on like the tiniest little microcontroller. Or you can do register fiddling by default because you don't trust Arduino libraries because they hurt you too many times to use them beyond the absolute basics. I like to keep it through the basics here. I like to keep us away from doing the hardcore memory stuff, mostly because it hurts me to do. It's too specific and I have to look stuff up all the time. And I also feel like this job of outputting a 40 kilohertz square wave on 4 pins, 1 phase delay, 2 opposite, it should not be that hard of a task. This should not be that difficult of a task to do. Generate a sync signal of 40 kilohertz on pin 10. So I think what they're doing is they're doing what I thought with that sync pin. And each cycle, so if I output 40 kilohertz on 1 pin, and I have a little piece of logic that looks at the things, but the delays I can't actuate the delays. I need the delays, the phase delay to be intrinsic to the whole thing. Iterate is one away from irate. That's pretty good. That's pretty good. I like that. So I'm just trying to think of how I can do this. I've got some timers in use already with the button stuff, with all the butt stuff that we're doing. But that's why I'm thinking tone library would have been the best way to do it. It's just I don't think a lot of people have tone libraries doing the stuff that we want to do. Anyway, all right, this is distracting. Let's get this out of the way. See, I don't want to use the NOP specific weird timers and program them into like output wave emitting pointer of pin blah button pressed. That's crazy. It's crazy. Works well, but yes, I understand. This is not asking a whole ton of the Atmega 328p though. This is still not asking a whole ton of it. I wish my Google search for the Paul Stoffrigan audio library for the Atmega 328p could have come up with something, because that would have been the easiest way to do it, because all I would have done is put down building blocks and just steal all that code and put the stuff in. That's basically how I did the module tester module. And so if I threw a teensy at this thing, the teensy's fast enough that it would be able to just eat this project in 5 seconds. But because of my brutal insistence on using old hardware, I am of course burdened. So anyway, note player, if we do, we'll just copy them. So tone note player of 2 going into my globals. It's an array of 2 because I've got 2 notes. Yeah, note player 0 and 1. All right, we'll start with that. It wouldn't be rewarding and fun if it was mega easy. I don't know. I disagree in this specific instance. The emitting pointer is how they generate the moving wave. Huh. Yeah, pointers and stuff is a quick way to make my head spin. So I'm hard coding this into here. This is not the way that anybody should be doing this stuff, but we're doing this just for the purposes of testing it quickly. Hopefully that's able to output a note on those pins. And I'll need to give it notes. What am I giving it notes for? Tone note player of 2 is equal to, we'll just give it the whole array. Note A, B, C, D, E, F, G. And so over here, we have a guide to the notes. That was the other one, the other tone library. There's 2 that are called the same thing. And they're used in the same exact way. But if we want to get to 40 kilohertz, wow, okay. 440 hertz musical note from the 4th octave of A on pin 13. Note A4. A6 1760. I need to get up to, this is like getting outside of note nomenclature. Can I just give it a frequency? Although F high can go as high as 8 megahertz. Can't quite go. Oh, I don't need a Wikipedia article on the human hearing range. Okay, after all said and done, play only accepts unsigned integers for frequency. The maximum frequency that can be produced is 65,535 hertz. So instead of begin, I want to be using play. Examples, or what's going on in, this is the example. Print line, notes player, stop, play. Oh, and then it takes it into a function. Okay, so note player of 1 and 2? I'm getting there, Chad. Note player of 0 and 1. Where do we set up our pins? Begin. So begin is the pin. And then we note player of 0 and 1 play. And then I can give it 40 kilohertz. I don't need to do any of this nonsense with tables. Begin and then play. Really? Play? Okay, it doesn't highlight. 40. Here's a 0. Probably maybe not put the comma in there. That might screw it up. And then delay of microseconds. 5. See what that does. What happened? What'd I miss? 16-bit max in? Yeah. Recently started learning to play the ocarina. If you're Rich Evans, you say Ocarno of Red Letter Media. They long time ago they were streaming and they were playing Ocarina of Time. But Rich had only ever read the word, which there's no shame in only ever having read a word. That means you're well read, right? But he called it Ocarno. Ooh, it's hard to listen to. Trying to learn what those notes and numbers next to them mean. Oh, that's pretty neat. I used to sing, and it's really frustrating for me because having sung, I had always been really good at just intuitively reading sheet music. I was pretty good at that, but you know, I had only sort of loosely interacted with the sheet music through my high school career, and then Deltarune came out, and the latest chapter 4 chapter has like this underlying visual of things falling that very much resembles sheet music, and I did a little bit of like pixel by pixel analysis of the stuff going on, and it's definitely, according to me, sheet music on those things. It is Toby Fox, Tricky Tony, putting something right in your face that says, hey, here's a leitmotif based on what just happened with that. And you're like, you're trying to say something to me and you're trying to be sneaky about it. And I like adamant, like a dog with a chew toy. I had to make sure that I figured out what that was. And my sheet reading music ability is just not there. He tried to pull one over and he won because of my inexperience with it. And this is Toby Fox. This guy is a very highly skilled piano player who knows how to read sheet music. And the whole chapter has a theme of playing the piano. And there's underlying themes of losing your ability to play piano. I have lost my ability to play piano. I do not want to go back to practicing it. Eventually with the synthesizer project, I'll be able to hook up at least just like a keyboard key and noodle around with that a little bit and maybe get to know it a little better. I'm not going to learn how to play it on the automaton, for fuck's sake. So I don't know, my engagement with this, it's like I know there's something there. I know that's gold. I can't figure it out. I can pop the lid on this whole thing, the whole conspiracy, top to bottom. Note player, play note B2, delay 300, note player 0, stop. Okay, so that's a little different. But so with this, the question is, are we going to get two square waves that are slightly out of phase with one another? Piano takes a lot of time, no? Like violin. It's a little bit slightly more forgiving compared to what? I don't know what you would compare it to, though. Piano takes a level of confidence that you are hitting the key in precisely the way that you intend to hit the key, because it will replicate what you do on that key. And we have a keyboard, a MIDI keyboard that will do that. And if I get the right MIDI stuff, I could hook up the synthesizer so that it does represent attack and decay and all that stuff that's happening with the key, so you can get the subtlety of the piano player. However, the memorization of muscle memory and sort of the association, being able to do the little trills, the doo-doo-doo-doo, at the end of like a thing, I'm not good with that stuff. It basically takes practice to get to know your instrument, believe it or not. Wow, what a crazy world we live in where you have to practice the instrument that you want to play skillfully. Not getting anywhere near a pleasant tone on a violin takes years. Piano just sounds okay by default. If you hit the right keys at the right time, and it'll be fine. You do need the confidence. You need the confidence, though. I would definitely say violin is a whole lot more difficult to get the sound out that you want. We're uploading the code. The code's going in. It's going in. There's no mistakes. Never any mistakes. But yeah, I mean, aside from your piano going out of tune and having to get somebody out to fix it, hitting the right spot on the violin can be pretty difficult. Note player was not declared in this scope. What's your problem, note player? You got a problem with me? Note player of 0 and 1 begin. Tone note player 2. Oh, so I do need this. So we'll go down here to my globals. That's not a global though. That's like a declaration of independence. Yeah, whatever. I'll just put it there. So tone note player of 2, and then we've got note player of 0 and 1. Okay, so that makes more sense. We need to actually declare the stuff that we're using. I think an O-bother could tune their piano themselves. We had a grand piano and it had a cracked headboard and couldn't be repaired. Very sad. That was a nice piano. Probably should have kept the whole thing and turned it into a shelf. Or a big glockenspiel. Oh my God. Oh, this is promising. Wait a minute. Tone might have it, even though some weird stuff's going on with the shifting there. Of course, that other waveform is like tortured. I don't know what all the glitching is about. I think that may be where the sync pin kind of comes into play. I am declaring these initially and just letting the rest of the program do what it wants. And so it's possible that there's some glitch timing delay in there where things aren't quite syncing up the way they should. Yeah, look at the jitter on the outset of the waveform. So we're looking at the far end of the waveform here and how it jitters back and forth. Because remember, we're not just looking at something that's going up and down. We're looking at something that's going up and down at an incredibly fast rate over and over and over and over and over and over and over again. And so when that trailing edge of the waveform starts to get loose, we can see that the timing is sort of drifting back and forth as the waveforms stack on top of one another. Tune a piano, but you can't tune a fish. The drummer from the Fluffers only got one arm. The drummer from the... Oh, wait, no, that's not a Bloodhound Gang lyric. We did get our delay, though. We got our phase delay, which is interesting. So on letting go of the button, I could potentially instigate a phase delay of a particular value. Now, I don't know if I think it goes to 0.5. I don't think it's going to be a very, like that other code, we were seeing like a really smooth waveform and it was varying like real smoothly. So I don't know what we can do with that. We're not basing our waveforms off of a single generation of waveforms in a way that's as predictable as that other code. That other code did some stuff that really cleaned it up. This is promising though. I mean, for next stream, I can figure out what I want to do with that specific thing. I think I'm the only person in the house right now and I need to take the puppy for a walk. And so we're gonna close there on what seems to be a pretty promising thing. Using the tone library, I might be able to make the 4 signals that I need to make, give them appropriate phase delays so that things come in the way they're supposed to. It's possibly that, yeah, the lookup table could stabilize it. I mean, maybe I could learn what they're doing, learn how they're doing it and do it in a more simplistic manner. That's a little bit more in line with sort of the way Arduino's philosophy to do things is. This is technically code in Arduino, but I think they did it for the blog cred because they're much smarter than us and they're dealing with these things on a much lower level. I don't want to deal with it on a lower level. I want it to be in the Arduino code and simple. The question is this jittery nonsense waveform going to be good enough for the implementation of the levitation machine? Or does it need to be clear? Now, thing is, I can always load their code onto this. I wanted to have the additional functionality of taking control over what the buttons do, so that I could have a button that turns the laser on and off. Bother, you really spent 5 hours on that? You spent 5 hours on literally all you wanted to do was turn the button on and off? Yeah, I did. Because also you could build in like a mode where it just moves the stuff up and down, turn the laser on and off. Listen, it's a very good reason for everything that I do sometimes. Don't you worry about that. I have not programmed in the end card. Let me do that real quick. I have to go to my super secret admin section, highlight my previous comment, look at today's date. It's very hard work, and put in the 15th. And then I have to actually hit enter. It's a lot of work. It's very tiring. Here is the end card. Bada bing. My blue sky got hacked, so don't worry about the blue sky up there. I probably should do something about that. Maybe by now I would have had 300 followers again. I don't know. Blue sky was fun while it lasted until something hacked me. So I don't know what to do about that. But, you know, the Discord link is in there, and I'll be back in approximately 19 hours, 21 minutes, and 4 seconds. And we'll levitate stuff. We'll levitate stuff first tomorrow, right? Because we got to hook it up to the drivers. Probably use the old software to hook it up to the driver just to make sure that it works. And then we can load our own code into there and see if we can get it to work under our terms. So I will catch you guys then. Until then, check to see if anybody else saw mine. What do we got? Oh my God, what's the flavor of the week this week? What is everybody doing? Battlefield. Oh boy, finally, a first-person shooter. I wish they would make one about World War II. Like, that seems like a pretty good topic to make a first-person... Oh, Davies is doing stuff, if you guys feel like watching a My Summer Car streamer. Aside from that, I guess I'm going to leave you guys to go where you want to go, because you're responsible, and technically you should be adults. Yeah, and we already saw the end card. I'll see you guys later. Where is that scene?